has joined them.
Okay,
Madam, good morning. Good morning, madam. Good morning, madam.
Good morning. Good morning.
Morning. Then we start, ma'am.
Yes,
Okay,
yes.
okay.
Please.
Look here.
Okay, ma'am. Every day is a fresh beginning and every morning is a world made new. A warm and a happy morning to one and all present here. On behalf of the Department of Electronics and Communication Engineering, I welcome you all to the Day 16 MGR Alumni Conclave 2021 on the topic, a Clarion Call for Self-Reliant SoC Design. A smile is a universal welcome. With the same smile, I request our dear HOD, Mrs. U. Jayalakshmi, to deliver the welcome address. Please, ma'am.
Yes, Ilakya. Good morning to one and all present here. On behalf of Electronics and Communication Engineering Department, I extend a warm welcome to every one of you for MGR Alumni Conclave 2021, a massive World Book of Records attempt, which is scheduled from September 25th to October 19th. Today being 16th day of the conclave, we have scheduled an event titled A Clarion Call for a Self-Reliant SoC Design. I would like to express my sincere gratitude to our founder chancellor, Dr. A.C. Shanmugam, and our Honorable President, Engineer A.C.S. Arun Kumar, for their constant support and encouragement in organizing today's event. It gives me massive joy to welcome our respected Vice Chancellor, Dr. S. Geeta Lakshmi, who has been a moral support at all our accomplishments. It is indeed my great pleasure to welcome our additional registrar, Dr. V. Cyril Raj, who promotes enthusiasm among us in all our endeavors. I feel delighted in welcoming our Deputy Dean Events, Mrs. Kriba, and thank the MGR Alumni Association team for the wonderful opportunity provided. A day like today is significant for us as it furnishes us the chance to meet our distinguished alumni. We realize that it takes a great deal to remove some time from your busy schedule and come over here to share your expertise. I thank each one of you for accepting our invitation and for your valuable time. With great honor and privilege, I welcome among us the alumni of our department. Our alumni have established themselves as successful individuals in the field they have chosen. We have with us today Mr. Shubham Srivastava from 2009 batch, who is a mechatronic system architect in Kulik and Sofa, Singapore. Mr. Suman Kumar Panda from 2009 batch, who is an analog engineer in Intel Corporation. We have Mr. Ravi Sharma from 2010 batch, who is a senior lead engineer in Qualcomm India Private Limited. From 2020 batch, we have Ms. Pavni, router expert from Amazon Logistics, who will be the moderator of today's event. I wish to stretch out my sincere appreciation to Mr. N. Lakshmi Narayanan, alumni coordinator of our department, for his contribution in organizing this event. I cordially welcome all my dedicated colleagues for the Alumni Conclave event. Last but not the least, my hearty welcome to the present students, and I'm sure that you will be highly motivated on interacting with our alumni experts about the technical happenings in the core domains. Have a good time ahead. Thank you.
Thank you, ma'am. I now request our respected Vice Chancellor, Dr. S. Geeta Lakshmi, to deliver the felicitation address. Please, ma'am.
A very good morning to all, and it's a pleasure to be with you all on this afternoon or Sunday. In fact, in spite of my Sunday engagements, I still made it happen to come to the conclave conducted by the Electronics and Communication Department and make them feel happy, and so that they go ahead in progressively in their departmental activities, research, innovation, entrepreneurship. And this alumni conclave definitely makes this possible on the today's event, where the semiconductors, the transformation of semiconductors, and how to manufacture in our own in-house preparation would definitely give a lead role by our alumni who have been leaders in their own field here in India as well as abroad, where we might be self-sustained in our own way, rather than going out and purchasing from small electronic which is used in our software. in other countries. So I think so this would make it this possible with a helping hand to our Dr. MGR Educational Research Institution to guide the students and to make entrepreneurship or create opportunities for the students who will be passing out, and also in collaboration with other because as you know, like electronics and communication is the department which integrates with all other departments, from medicine to whatnot, from rocket to anything. So it is we who have to develop with the help of the passed out alumni and the faculty and the students who would be the future Indian citizens. Thank you one and all for inviting me on behalf of the management. I welcome you all and thank our AC Chairman AC Shanmugam and President ACS Arun Kumar for giving you all this opportunity to have a get together. Thank you. Thank you once again.
Thank you, ma'am. Thank you very much.
Thank you, ma'am. Thank you for motivating us to explore the technology. We will surely explore it. Now, I request our additional register admin, Dr. Cyril Raj, to deliver the special address. Please, sir.
With my profound thanks to our Founder Chancellor, Dr. A.C. Shanmugam sir, as well as our beloved President, Engineer ACS Arun Kumar sir, for providing such a wonderful opportunity in the name of Dr. MGR Educational and Research Institute for all of us to excel our career. My sincere respect and then thanks to our enthusiastic, motivating Vice Chancellor, Madam Dr. Geeta Lashmi. Every day she calls for updates on all activities which are happening there. Thank you for your valuable guidance, Madam. Dear alumni of Electronics and Communication Engineering departments, really we are proud of all your elevations. In most of the meetings, I used to call the alumni as one of the important key role player of an institution. So it is something like if you take any vehicle, so definitely it should minimally have 4 wheels. So one of the wheel is I can say that it is that alumni. So if that particular wheel is not properly inflated, so definitely we cannot reach the destination properly. So what I'm trying to say is a healthy contribution of alumni is always important for any institution to sustain also. So that's why in our academic system, we made alumni participation as compulsorily in case of the Board of Studies of the particular department or CDC, that is Curriculum Development Cell of that particular department, as well as in the university level apex body like the IQAC, that is the Internal Quality Assessment Cell, where the say of alumni are very, very important for all of us. Dear alumni, when you were there in your alma mater, clear, so we were helping you as a ladder. So now you have gone up to the ladder. Now you have conquered the profession where you are working, but at the same time, we should not keep the ladder remaining in the same position itself, because actually what I'm trying to say is you only know how the technology are developing. You know that there are a lot of gap between what we have taught you in the classes as well as what right now you are practicing. So definitely we will be successful, or your juniors will be successful unless this particular gap is brought down. So that's what actually we are requesting you. Please keep in your mind that at least once in 6 months you should visit your alma mater and then engage in different possible ways. So one of the possible way is you have to know the developments, and then you have to, through us, you have to reach your juniors also, and then we need to have a constant mentoring also by you. Some handful of students should be properly mentored so that they can come up to your expected level also, and then say sometimes the internship assistants, and then sometimes the placement assistants. So these are some of the things. If you see some of the when the Western universities, even IITs, where it is millions and millions of dollars are only pumped in only by that alumnus of those institutions for the sustenance or the improvement of that particular institution. But anyway, we are not looking for any such financial commitment from your side, but rather we need your intellectual commitment to us, because actually it is ultimately it is your institution. So always you have to proudly say that I am from this MGR Educational Research Institute. So hope you understand it's a win-win situation for all of us. So definitely I request all of you to participate in the activities of our university, so that so we can reach the heights. So with this, I have to thank Dr. Jailashmi and her team for arranging such a wonderful alumni to motivate our existing students. Thanks a lot. I wish, I pray to Almighty God that you'll be flourishing in your career. Thank you.
Thank you, sir.
Thank you very much, sir.
Thank you, sir. Thank you for inspiring the alumni to attend the juniors and guide them. Thank you, sir. I now request Mrs. T. Kriba Devi, Deputy Dean, Alumni, to ceremonize on MGR Magic Association.
A very happy Sunday morning to our respected Vice Chancellor, Madam, Dr. S. Geethalakshmi, Additional Registrar Admin, Dr. B. Cyril Dutt, sir, HOD of ECA Department, alumni panelists who have gathered here, faculty members, present students, and one and all present here from the Department of EC. Today is day 16 of MGR Alumni Conclave 2021, which is a massive world record attempt in connecting 25,000 participants with alumni speakers through conclaves for 25 days as a part of our
Ma'am, your mic is in mute, ma'am.
I think we lost her.
I can't hear anything.
Yeah.
just now or from the beginning. Can you hear now?
We heard you like in the beginning till nice Sunday morning. After that, we didn't hear you.
Oh, I'm very sorry.
Yeah.
Suddenly I got a request in between, so I got confused whether I'm connected or not. So that's fine. Thank you, thank you. Now, actually, can you hear me?
Yeah.
Yes,
we
sir.
can.
Yes, yes.
Okay. Yeah. Thank you, thank you. So let me start again. Very happy Sunday morning to our respected Vice Chancellor, Madam, to our Registrar Admin, HOD, alumni panelists, faculty members, present students, and one other present here. So today is day 16 of MGR Alumni Conclave 2021. And as ma'am said, it is a world record attempt in connecting 25,000 participants. And we are connecting 25 conclaves for 25 days from various departments every day. So I would like to summarize the outcome of Dr. MGR Alumni Association. So MA is now, we can proudly say that MA is a registered society with a register number SRG Chennai South 340/2021. It has works with the motto of stay connected to share and care. We have around 5 international alumni networks.
I think we again lost her.
Kruba ma'am?
Yeah, ma'am.
It has got
Can you
interrupted
hear
just.
me? Shall I continue? Because I don't know whether my connection is problem or problem. Okay, let me come and finish now. So we have 2 alumni portals, Alma Connect and Ma Connect, with 26,000 alumni students associated, and around 160 abroad students and 200 national students have been benefited through alumni service. Various alumni services provided, such as providing transcripts for higher studies, issuing mark sheet if you have missed it, providing bona fide certificate for medium of instruction, and issuing LOR from the department. So all these are online services. You can contact MA office or you can mail to alumni at drmgr.du.ac.in. We also organize 3 silver jubilee reunions and 4 decennial reunions today. With the host. Yes. I wish that PC to succeed with this.
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you, ma'am. Thank you for briefing us on MGR Magic Association. I now request I now request Mr. M.N. Lakshmi Narayanan, Alumni Coordinator of EC Department, to perorate on today's topic for the conclave. Sir,
Yeah.
please, sir.
Good morning to one and all present here. So it gives me great pleasure in conducting an alumni conclave with the topic Clarion Call for a self-reliant SoC design. Right. So as the pandemic occurred in the late early 2020, we have started looking for there is a great demand for semiconductor devices, particularly in India. Right. Since although we develop a lot of electronic products like most of the mobile phones being manufactured here, the raw materials being used, that is raw materials means here I'm talking about the semiconductor devices, which are quite often we need to import from even from smaller countries like Taiwan, Korea, and some other Southeast Asian countries. So we need to go for since although we have enough human resources, we are not in a position to actually tap the potential of our human resource persons available here. So it's a right time. There is an urgent need for us to develop a self-reliant SoC design. Right. So SoC is actually a system on chip. Everything is being integrated into a chip. Right. So that actually stems from the basic analog and integrated circuit technology. So if at all we are able to produce it on our own, right, that's what we call it as self-reliant. Right? We need not depend on others for extracting the right. So it's the right time. That's what I have mentioned it as a clarion call. So it's the right time to go through our basics, develop our engineers into an R&D professional who are capable of doing it. What we need is to take this to a self-reliant semiconductor device technology manufacturing facility quite available here as we are having raw materials for other materials like textiles. We are having enough amount of cotton, something like that. So if we are self-reliant in these technologies, hope that will cut the import cost of our government. That will make India a flourishing electronic hub. Although it looks a software hub nowadays, it will in the near future will remain an electronic hub. With this, I am extending a warm welcome to all the panel members who, despite their busy schedules, right. So whenever I need to tell you something when I find people for very hardcore people, right? People studying in electronics are always going towards lucrative job careers in software, right? So when I ask people, it's quite difficult for me to find people from people working in hardware science. So despite all these difficulties, we have managed to bring in people who are working in 4 sectors of electronics engineering. So thanks for coming and grace the occasion. And now I am just over to. Thank you.
Thank you, sir. Thank you for briefing us on today's topic. So it's time to introduce our panel members, our proud alumni, who are the pillars of today's event. So now I request Ms. Haripriya, third year EC student, to introduce our first speaker, Mr. Ravi Sharma.
Good morning. Okay, ma'am. Good morning, everyone. I am Haripriya from AC department. Let me introduce one of the panel member in this session. His name is Ravi Sharma. He have been working in semiconductor industry for last 8 years and have worked in ST Microelectronics Intel in the past. And now he is currently working as a design lead in Qualcomm. His working domain is timing analysis at SoC. Ma'am?
Yes, ma'am.
Ma'am?
Yes, you can. We are hearing you. You can talk.
Yes, Haripriya, you can continue.
Ma'am, can you hear me, ma'am?
Yes, ma. Yes, ma. We can hear you. You can continue.
Yeah.
Okay, ma'am. Ma'am, that's it, ma'am.
Okay, ma. Thank you.
Okay, ma'am.
Now I request Ms. Guna Priyadarshini to introduce our next panel member, Mr. Shubham Srivatsava.
Ma'am, wait a minute, ma'am. She has to made a host actually.
Oh, okay, sir.
Am I audible, ma'am?
Yes, go ahead, Gunapriya.
Yes, ma'am.
Good morning, everyone. This is Gunapriya from EC department. Let me introduce one of the panel members of this session. His name is Mr. Shubham Srivastava. He completed his BTech degree of Electronics and Communication in the batch of 2005 to 2009 in Dr. MGR University and pursued his education in Singapore 2009 to 2011 by doing a master's degree in Advanced Controls. He is an expertise in domains such as high precision machine design for semiconductor manufacturing, advanced motion control and firmware, vision system applications and optimization algorithms. He is now a mechatronic system architect, team lead in systems engineering, and currently employed in Singapore. Thank you.
Thank you. Now I request Mr. Shai Shravan of third year ECE. Yeah. Thank you. Now I request Mr. Shai Shravan, third year ECE, to introduce Mr. Suman Kumar Panda.
Yes, ma'am. Am I audible, ma'am?
Yes, ma'am.
Yes, go ahead. Go ahead.
Good morning, everyone, and welcome to today's session. I'm Shravan from ECE department. It's my pleasure to introduce you to our alumni, Mr. Suman Kumar, an analog engineer from Intel. He completed his graduation from Dr. MGR University in the year 2009 and pursued his master's in microelectronics from BITS Pilani in the year 2011. Since 2011, he has been associated with Intel India, where he got hired in a mixed signal design group, which is a full custom group. His initial career started with participating in designing loop stability of DC-DC buck converter voltage regulators on chip and till tape-in, which is quite complex. That is informal equivalence, integration with RTL, reliability, guiding post-silicon, and some miscellaneous DDR blocks. After a while, he has been working on complex I/O designs. He architected current and voltage compensators for design stability across industrial SKUs. Since 2018, he has been working on best-in-class of art next generation DDR. Currently, he has been contributing to next generation SerDes and Ethernet receiver architecture design. Thank you.
Thank you, Shravan. Now I request Mr. Rahul to introduce the moderator of today, Kunjapalli Pavan.
Good morning, everyone. I'm very enlightened to introduce our moderator speaker, G. Pavani Chaudhary. She is a BTech graduate from the year 2020 from of ECE department from Dr. MGR Educational and Research Institute. She started her career in this college days as a project in incubate in Dr. APJ Abdul Kalam Center of Excellence located inside the university. She was head of technical operations, Asaya Foundation as a freelancer. She had an internship in Sutherland Global Services during her final year of study, and she is now working at Amazon Logistics as routing expert. We are so happy to have such an ambitious girl in this event. We welcome you, ma'am.
Thank you. Thank you, Rahul. So now it's time to start our event. So Lakshmi sir, you can take over from here. Thank you.
Thank you, Ilakia ma'am, for coordinating the event.
Thank you, sir.
Now over to Pavani.
Thank you very much, sir.
Okay.
Hello, everyone. A hearty welcome to everyone, all the panelist audience and our respected faculty members and the organizations here. As you already know, my name is Pavani. I am from Dr. MGR University, passed out alumni of 2020, and I'm from EC department, currently working in Amazon Logistics under SDS sector. So today here we are to just go into the direct topic. Here we are today to discuss and deep dive into the self-reliant SoC design, which stands for SoC system on chip, which we'll be going to discuss further. Now, even though everyone has already introduced our panelists, just me officially welcome them again one by one, so that the people who have come again will know who are there. I welcome here Ravi Sharma, super lead engineer, Qualcomm. He's a passed out of 2010. Good morning, sir.
Hi, good morning, Pavani. Thank you.
Good morning, sir. Thank you for taking your time and welcome. And next we have here Shubham Srivastava. He's a mechatronic system architect from Colfic and SOFA, and he's an alumni of 2009. Welcome, Shubham. We are glad to hear.
Yeah, hi, good morning, everyone. Good morning to all the panelists and all the invited attendees. Glad to be here.
Thank you for that. And next we have here Suman Kumar Pandey. He's an analog engineer at Intel and alumni of 2009. Welcome you, sir.
Hey, hi everyone.
Hello. Now let us talk. Next we have slitted our today's session into 6 rounds, which we'll discuss one by one further. As for the first round, let us hear from our panelists itself about their current position and their journey to the current position, from which we might get an very interesting inspiration and the ways they have of their way to their current positions. Now, let's us go with the alphabetical order. Now, I request Mr. Ravi Sharma, please take on the lead and let us know the journey to your current position, please.
Thank you, Pavni. Thanks. So I'll just, as Haripriya has already, introduced us, but anyways, I'll just start with a little bit introduction that I'm an alumni of MBA 2010 batch, and I did my BTech in Electronics and Communication from there. And I went for MTech in VLSI technology, okay, that I completed in 2012. And then I immediately joined, ST Microelectronics, that is one of the semiconductor giant of our time. And I have almost completed 9 years now in the semiconductor industry. And in the past, I have worked with semiconductor companies like Intel, ST Micro, and I'm currently working with Qualcomm, which is a world leader in 5G cellular technology mostly. So, if you're carrying a smartphone with you, there is a good chance that you are using Qualcomm's hardware with you. So that's all about me. Now, since I think what I feel that the purpose of this event is to motivate the students who are currently, pursuing BTech there. So I think it's important to motivate them or to guide them how to, enter into the semiconductor industry. So what I would like to say to the audience today, mostly which are from the electronics background, the students. So if you have really decided that you want to get here or you want to enter into this industry, I would say that start working on it right away. And in our BTech days also, probably in my days or in your days also, you must be hearing about things that there are not enough opportunities in India. At least in electronics industry, but I would say that don't listen to those words. What I can say that, at least in the current situation, we are really short of competent manpower around the globe, including India. So there are enough opportunities in our industry. And over the past, 5 or 6 years, or maybe a decade, the industry has, grown many folds over the years in India. So I can assure you that this trend is going to continue for a long time. So you will have ample opportunities to enter the industry. So if you have decided that you want to be a part of it, I would say just start working on it. And how you start working on it, so see now, when let's say when you going for an interview, final year or after passing out, you will go for an interview and you don't know what we are going to ask you in an interview. So I would just say that nobody is going to ask you to write a VSDL code for a complex circuit. Nobody is going to ask you. They will ask you about all the basics which you have studied in your 4 years, the project on which you have worked in your final year. That's the important part. So what I would like to say that everything there, what you need is everything is there in your curriculum already. I think maybe a decade ago we would be talking about the industry and academics gap, but I think we have passed that barrier, and many things has already been incorporated in our academics that will help you to enter the industry, and you can grow there. So just focus on all your curriculum, and you will definitely get it.
That was very inspiring and very informative too. Thank you, Mr. Rakshava, for sharing everything with us, and we'll try to incorporate what you have said in our daily lives for sure. And now let us move on to our next panelist, Shubham Srivastav. Sir, it's up to you now. The podium is yours.
Yeah. Hi, good morning, everyone again. I am Shubham, as introduced by Pavani earlier. So yeah. So we were told to talk something about our journey from, so since we started from our undergrad from Dr. MGR University. So I would say the journey was, it was full of hiccups initially, but at this stage, when I look back, I mean, I graduated from MGR University more than a decade ago, so 2009. But when I look back and see, it was a wonderful journey. Technically as well as socially and personally, it was a very fulfilling journey, and it is still going on. And yeah, so I graduated from MGR 2009. After that, I wasn't very sure, just like an average engineer is in third year or fourth year, but I was blessed to have wonderful faculties who always kept motivating. Lakshmi Narayanan sir, who also taught us a few subjects, Sudaman sir, late HOD Ravi sir. So they were all very, very supportive. I believe that even other panel members who were that time, they would agree to that. So yeah, it was a very motivating environment, and I continued to study, and I came to Singapore for my master's from NTU, which is a university here. Yeah, I did my master's in advanced controls, and since then I have been working in semiconductor industry. So yeah, the journey was full of hiccups initially, but at this stage, I feel it was very fulfilling journey, and I believe it will be in the times to come. Thanks to the start given by Dr. MGR University, and all the faculty members and all the students with which I studied over there. It was a wonderful environment. I would love to go back if I am blessed with another life. I would love to go back to that phase and have the same faculty members and the students with whom I studied, juniors, seniors. It was just a wonderful thing. So anyways, so talking about the coming back to the topic of today, a clarion call for self-reliant SoC. I believe, and I fully agree with what Ravi said initially. It is going to be a technology in demand in the times to come. So like what if you just seek my opinion, I would say that India has seen a lot of other revolutions, like how BPOs were in 1990s, and how IT industry has flourished in the last decade or so. I am very confident that semiconductor industry, and especially manufacturing in semiconductor, will play a very significant role in the next industrial revolution in Southeast Asia, and especially India, for sure. Because I mean, I don't want to like get into a political battle here, but we do know that West and East, China, US, things are not going smooth, and China has been capturing a lot of footprint in the semiconductor manufacturing. So things not going smooth, US and China. It is time for India to gear up for that and brace this and capture all the things for advancement in this semiconductor manufacturing. I do believe we have a lot of potential, but in that area for semiconductor manufacturing, there are a lot of OSATs operating in Southeast Asia. Name them, like if you go to countries in Indonesia or Taiwan, and you throw a stone in the air, and it will definitely land up in a semiconductor manufacturing fabrication area. So we haven't been in that situation, and but the potential in India is there, but definitely we can't go there just immediately. We are not. I do believe that even though we have potential, we also need a lot of training, and we need to focus our curriculum in that industry and make our next generation or even the coming generation prepared for that in the next coming 2 to 3 years. Because when it comes, we have to be prepared with that, and we have to encash all that opportunity. So yeah, what Ravi said, I also agree with him. It's not like you have to learn everything on day one. It has to be a structured process. Like we have a lot of people who are skilled in IC design. We have a lot of people who are mechanical engineers. We have a lot of people who are in other domains. But now the semiconductor needs, you need to have a gel of different engineering domains. You need mechanical, you need systems, you need controls, you need software, you need everything. So we need to divert our thinking to, like even if we talk about curriculum that we are being taught, a mechanical engineer studies mechanical engine, electrical engineer studies electrical. But we need to come up with things like, like interdisciplinary courses, which will help to channelize the thinking of the individuals in this direction and grace the opportunity with both hands for semiconductor manufacturing. So yeah, I mean the opportunity is there. It's for us to gear up, learn new things, new technology, and make ourselves grow. And yeah, so that's what I what I would say about this thing. And it's a wonderful platform here to start this discussion. And hopefully we'll, whatever we learn here today, I would love to be a part of the follow-up sessions in future. If the existing students over there need any guidance, I would be glad to help them. Yep,
Okay.
over to you, Pavani.
Thank you very much, Shubham, and thanks for standing up for the follow-ups. It might mean a lot for the few of the students who are really enthusiastic about the microprocessor, and hope our country will take it further ahead and give us more opportunities in the core fields. Now, moving on to our second panelist, the final panelist, the Suman Kumar Pandey, analog engineer. Sir, it's over to you, sir.
Hey, thanks, Pavani. Hey, so by the way, I'm Panda, not Pandey, and this I have faced even in my school days. And yeah, so it's fine. So yeah, I think Ravi and Shubham nicely articulated on multiple aspects of semiconductor industry. So yeah, I think Shubham and I were in the same section, same batch we are, and we do share a similar kind of a hiccupish journey as he mentioned. But I think when I look back today at what I learned in MGR, or the main thing that I learned over there is something called stubbornness. Stubbornness in the sense that whatever obstacles you face, you have to stand up to it, and you have to be uncomfortable, and then you have to conquer it. That's the whole. Maybe it kind of came in my mind, and it has now become my mantra that if you are uncomfortable and you are trying to conquer it, you are growing. If you aren't, if you're in a very comfortable place, that means there is some problem with you actually. So that is the main thing. So yeah, so about my journey, yes. So we started in 2005, and yeah, I felt that we were nurtured very well in our first years and second years as well. And there were some lot of hiccups that happened suddenly because of multiple reasons during that era. And yeah, but we overcame each of them. And I think luckily, I was also lucky that maybe in third year itself, I got placed. I think the first company where I was placed was Keen International. But there was one thing that we realized. I mean, I would give even credit to my friends as well. We had such a ecosystem around. We were all into core electronics. At least my whole gang used to be in core electronics. People used to innovate a lot on microcontrollers, and they used to take part in all kinds of robotic competitions. So there was always an environment of electronics around. And I think we had in our mind in third year itself that we kind of want to aspire into an electronics domain, basically. And we wanted to actually grow ourselves in that domain. So I would tell you that in my third year itself, I started preparing for GATE, because that was the next thing that I wanted to do, mainly to get more knowledge and get more expertise in the field in which I want to work. Because EC is a very broad subject where you have electromagnetics, you have electronics, you have portion of electrical, you have communication systems. So then I thought of that, yeah, I need to go into microelectronics field. And yeah, and as I said, my ecosystem itself was always motivating me to go into microelectronics. So, and then I prepared for GATE as well. And then we cracked the GATE. I cracked the GATE. Actually, all my friends did crack the GATE. And as a result, then I looked for opportunities. And then I also gave BITSAT, and then I got into BITS. And then post BITS, basically, that was another game altogether, because in BITS, what I understood is I have a certain level, and now I'm going into another level. So again, the whole fight again started, like, how can I actually surpass here, and how can I be a better designer in BITS? And then it gave me that platform that I wanted, where I wanted to enter into some of the, basically I always wanted to enter into core design. That was my main aim. And I got lucky, I would say, that in our first placement itself, I got into Intel. And yeah, I also got an opportunity in NVIDIA, but it was more into digital. So I said, no, okay, I'm an analog designer, so I want to be in analog. And that's how I got into Intel. So the good thing, or what I've learned, is all this, if you go into big companies, you actually enter into a sea. It's a giant company with an ocean of technologies that are present there. You want to be in electronics, you can, I mean, in electronics itself, we have read so much, and you will be surprised to know that each and everything is applicable in the VLSI industry. In fact, as Shubham pointed out, even mechanical is there. I mean, mechatronics is a very important part our industry, and even biomedical instrumentation, BMI, is also a very important part of this VLSI industry. So there, when I joined, I started my career. Yeah, so okay, it was analog. Yes, of course, transistors. And the why analog I cherished was I wanted to be in. It's a full custom flow basically. So when you do a full custom design. So by the way, the full custom design means that you go through an entire process till tape-in. There are simulators, but there's no as such any digital automation to really make the design work. You have to actually do hand calculations and then make the design completely, and then simulate, and then basically you have to draw the layout of it. You have to see how it is integrating with the rest of the SoC or the rest of the protocols which are going to invoke your design, and then finally you have to once you bless, it goes for tape-in. And just understand the risk of tape-in. One tape-in can a day means, for example, if you create a fault in your design, a day loss can go as high as $200 million once you have taped in. So the products on which you work basically have a revenue of around $5 to $10 billion. And then a single day of lag, it's something called time to market. You lose basically $200 million on a single day if you're late in the market. So that is the complexity there. So each and every part of the design is complex, and you have to put due diligence there. So so I started with DC-DC buck converters, and of course I was ramping up over there. And then I thought that, fine, I am interested in DC designs, DC or the low frequency designs, but I do want to go into the more competitive market, which is a high-speed design or something like that. And then basically I looked for opportunity within. As I said, Intel has plethora of technologies and plethora of, because it's an SoC, the word SoC means hundreds of things on a single chip. So then I went into, I somehow caved into my way into the high-speed IOs. And then from high-speed IO, I have always been on the edge, always been trying to make the design as best as possible. And I've been continuing my journey on this. So so high-speed IO again has DDR and SerDes. And once you will go into masters, you will again learn about what are the different architectures which are there in IOs. Something is called clock-forwarded architecture. Something is called continuous clocking architecture, SerDes systems. So yeah, overall, when I look at myself, right, what I feel is the most important thing, as I said initially, you have to be passionate. You have to be stubborn. No matter whatever happens, you have to have a goal in mind, and you have to reach. You should not settle till you. It's like the OnePlus motto that is there, right? Never settle. So you should never settle basically, unless and until you are achieving what you have in your mind. And today, I mean, after 11 years, if I look at the opportunity around me, there is abundant opportunity. I mean, if you look at India itself, Bangalore is one of the state-of-the-art IT sector. Well, by the way, when I'm saying, I don't like to call IT though, I would say an electronic sector. And then second big hub is Hyderabad. In fact, if you look at Apple has an R&D in Bangalore, and then they have opened a manufacturing center they're planning to open in Hyderabad, or they have already opened. Intel has a new center in Hyderabad. So Intel was only confined to a single industry in Bangalore, but now it has expanded. When I joined Intel, the total employee count was around 3,000, and today it has surpassed 10,000 plus. So Intel has become now a next big R&D in India, because they are actually getting such. Yeah, so they are actually getting such kind of people from India. They're getting that pool from IITs and all the premier institutes. They are getting that kind of talent, because earlier, I remember about 10 years back, right? There was a notion that US, there was a notion that US institutes are much better and Indian institutes are not that up to the mark, but that's not true though. Yeah, I do agree that we don't get that much of exposure, but then we have a lot of mathematics and a lot of logical reasoning is embedded in our mind. And now basically all the industries in India, right? I'm just telling about Intel, but I will name a few more. Like there is.
So your voice is unmutable.
Someone, you're muted.
Yeah, sorry. So basically, where was I then? I think, so I was saying that not just Intel, even companies like SanDisk, be it AMD has opened its own DDR center here. They are going to So note, when I say DDR and HSIO, you can think that it is kind of cream of microelectronics, because these are very high-speed complex subsystems, which are actually coming into your in your current generation, and it will be very much prevalent in the future generation. I think be it 5G systems, or be it Ethernet system, or be it existing DIM CPU interface, all these are actually catching up to Ethernet speeds. Ethernets are like way ahead in the game. So so when you see that India itself is growing an Ethernet system or a service system, and I'm talking from these references because I work on that, what I see is that there is a realization that India has that pool of people who can actually deliver such complex systems, and as a result, they are increasing their presence in this country. So I think overall, I would say opportunities are humongous. You just need to be able to grab those opportunities. That is what your target should be. And please, if you have some aim, don't get perturbed by some of the hinders that you might see. Maybe you did not crack a gate, or maybe you did not get a very good institute, but there are always opportunities through different ways where you can enter the same industry. It's just that maybe it was smooth for somebody, and for somebody else it was basically a hindered path with a lot of obstacles, but then finally you can reach your goal. I mean, core is nothing like you can't. Core is easily achievable. It's just that we need to have that concept, that grasp within ourselves to grab the opportunity whenever we get. That's it. Thanks.
Thank you, Suman. That was really very, very informative. Thanks for keeping a positive hope on Indian youth and Indian market in the core sectors. And I do completely agree that we have to be stubborn to achieve something. And if we are comfortable, we are not going to achieve something, because we are very comfortable and something is not right with that.
Yes.
Okay. Now it's time that we all waited for, the topic of the self-reliant SoC design. Now I request all the panelists, please go ahead and will request what is SoC, what the impact that made SoC different from the other microprocessor transistors or the laptop systems what we have. And I hope this will be very informative for the audience also. Over to you all the panelists. Thank you. And anyone can take on the first. I feel let's go for on the alphabetical order again. I request Ravi Sharma sir, please you can lead the starting the introduction of SoC, and you would like let us know what is it and what is the future in it, and everything that you would like to let our fellow students, like our juniors, know. Over to you, Ravi.
Thank you, Pauli. Thank you. So, I mean, we all are, electronic, we use electronic gadgets in our day-to-day life, and everything, is made possible because of the SoCs only, right? The IPs and SoCs, and, coming directly to the topic, today's topic, I would, like to say that it's not a one-day thing that, you become self-reliant on some technology or on something. It's an ongoing process, and we have reached a way, and there is still a lot to achieve as a country. And if we talk probably a decade back, we had a very handful of semiconductor companies in India who were working here, and with a handful of people. I mean, the strength were, as Suman already mentioned, that now the Intel has reached around 10,000 in strength, and even Qualcomm and other companies, they are growing manifolds here. But that was not the situation 5 or 10 years back, right? So it's an ongoing process, and the reason the industry is growing in India, the main reason is the competent manpower. We used to think earlier that we have good colleges or good people with technical know-how outside India, maybe in US, but that's not correct. If you see the strength Indians working in the US or there in the companies in the R&D side, you will find many Indians working there. So there are people among us only who are working on R&Ds, and they are doing very good. So that's the reason the semiconductor leaders, they believe in us, and that is the reason they are investing billions of dollars here. Some 1 or 2 years back, Intel opened their R&D center in Hyderabad. They spent thousands of crores rupees here in India, and same goes for other companies as well, like Qualcomm. They are growing. They are doing very well in India. They have announced several projects in India for R&D, and now they are entering into automotive part in India as well. Earlier, they were working mostly on the automotive thing in San Diego only, but now they have, they are planning to make a state-of-the-art center in Noida. Okay. So it's not that we don't have opportunities here, but yeah, we are surely lacking in many things. We are, there are still few gaps, which we need to fill as a country, or, as a person also, we need to make sure that we are competent enough. We are thinking out of the box, so we can, prove ourselves that, okay. So another thing, is, am I audible, right? Sorry.
Yeah, yeah.
You're audible, Ravi.
Sorry, yeah. So the point is that there are a lot of opportunities in India, and we are filling those gaps, right? Companies are investing in R&D here. Companies, another aspect which Lakshminarayan sir, initially mentioned about manufacturing here in India. So it's not that we haven't tried it in the past. In fact, India had one manufacturing unit in 1989 in Mohali. But unfortunately, some mishap happened, and we never went into production on a large scale. But in the past, there were 2-3 attempts, I guess, to start a fabrication unit in India, also, which were not, I would say, that fruitful. But if you are following the news recently, we have signed an MOU with the Taiwan government, and we have promised, have been promised an investment of $7 billion to start a fabrication in India. And, so you can, say that government or the leaders, technical leaders in our country, they are trying to make India self-reliant in all these things. Because manufacturing is one part, I would say that that we were actually lacking R&D and manufacturing. These are the two areas where we were actually lacking in India. We were, designing things here, but we were mostly, following the designs which were already, SoCs or IPs which were already designed by the people outside India.
Right.
We were mostly following on those things only. We are following the footsteps, basically. Yeah. I mean, all other things till the tape out we do in India, and manufacturing, we go to the countries like Taiwan or Malaysia, and in fact, after manufacturing, we do the testings here also.
Yeah.
Then we came back to India and we do the testing here. So that's one thing. I mean, I personally feel that over the 10 years, what I have learned, that we are lacking in R&D and manufacturing, but we are filling the gap. We are definitely filling the gap. That's all. I think, yeah, from my side, maybe on the manufacturing side, I think Shubham can, join and share his thoughts.
Okay, thank you very much, Ravi Sharma, for the exclusive detail on the manufacturing side of the SoC that we take into account for sure to further proceed with our goals. Then we will request our Shubham Srivastava, sir. You can please take on.
Yeah, hi. Thanks, Pavani, and thanks, Ravi, for I agree with like almost 70% of what he said. Like, I don't agree with a few things. So, but yeah. looking at things from outside India. So anyways, things to begin with, like getting back to the topic, just like let me take a small detour. So the topic is SoC. So I'm not sure so first question should be like why SoC? So I'm not sure. Just let me tell you guys something relevant. So like all the EC guys, I'm pretty much sure you guys must have been to the lab. You guys must have played with the, say for example, IC 555. That's my favorite IC even till date. So I'm putting those things on the board.
It's a Schmidt inverter, right? Schmidt trigger, I think. Schmidt trigger
Yeah,
series, IC
yeah, Schmidt trigger. I mean, you can configure it to this bystander and those kind of modes. I still use it. I'm still using IC 555 for making a play robot for my daughter. So that's my plan. Going in the background. So anyways, so like you must have remember, like you take an IC 555, you take some resistors, put it on a breadboard and things like that. But what if I ask you to make the whole thing in just like 1 millimeter by 1 millimeter size and get the same functionalities? So that's a question for today. And I'm pretty sure that 10 years from now, somebody will ask you to make that 1/100th of the size of what we are discussing today, like a fraction of a millimeter by a fraction of a millimeter. So, the answer why SoC, I guess an ex-colleague of Suman, Mr. Gordon Moore, gave a very important law. We call it Moore's law, which says that the density of transistors and integrated circuit will double every 2 years, and that curve is growing exponentially, and it will keep growing. And so coming back to India, so Moore's law has been true to mostly, even statistically, it has been true so far, and we have to cash in the opportunity of that growing curve. And like if you happen to know, like the starting of SoC is all just silicon dioxide and silicon. And I mean, if I know correctly, then India has abundant of raw material in terms of silicon. I think we are the third and the largest after China and probably some Russia probably. So that's what I know. So the potential is there for manufacturing, and just that we haven't explored that area. And what I also mentioned, that Southeast Asia, especially China and Taiwan, they have already at already a quite good level in that at those things. But again, what Ravi mentioned, I do agree that countries like China and Taiwan, basically they are OSATs, and the brain behind all those things is happening elsewhere as of now. And a part of that population is basically from our country. I would disagree. One aspect from Ravi is like what he says, that we do have the potential, and you see many places Indians are working. But and I mean, it's good to feel that you have a good analytical mind, because we are born with that. But it's not that other areas in the world do not have an analytical mind. So it's not that bad in the competition. People from other areas are all also equally talented. We are also, I mean, I won't say we are below average, but yeah, we are kind of average and above. But it's not like people in other countries are not talented. So we do have the competition. But having said that, we also have the potential to overcome that competition, because I mean, normally like 70% of the Indians do have a good analytical brain. So which is highly valued worldwide. And one of the reasons why you see a lot of Indians other ways is sorry, but it's the reality. But because we are quite a lot in number in the world, so naturally, if you sample 100 people, you will find 2 Indians over there. But that's just because there are a lot of Indians everywhere. And naturally, we have a lot of competition, so we have struggled a lot. We have put in a lot of effort. Our average education level is also pretty good, especially in Southeast Asia. So that's why you find a lot of people over there. And the second most important factor is most of us are bilingual. So other countries in Asia, especially China, Taiwan, they are not very good in English, and we can still manage some English. So we can help to communicate with Western world and even other people. So that's also one of the perspectives. So that we should also maintain those things. So again, to coming back to, so this is the one point which I don't totally agree with you, Ravi. Okay, we are there, but we are there just because we are big in number anyways. But we do have the potential. I do see, and we have to encash on those opportunities of the growing trend. And if I see, like, I have worked with like companies like the place where I work in now, it has an office in Hong Kong. We have a lot of fabrication units, silicon wafer fabrication unit, IC packaging units, fabrication plants, which are in Taiwan, in China, and we also have an R&D happening in US and in Switzerland. So I have worked with people from these countries, and I do understand, even when I go like to when I work with people in US or even Canada and Switzerland. So I mean, the first impression for an Indian is like, okay, this guy will do your job and he will do it for lesser number of dollars. So why not invest in India and hire him instead of hiring any other person? So that's also a good thing. Like if a company is setting up a fabrication plant in China, they need to pay, for example, $1,000 to a technician. If you are setting up the same plant in India, you pay $400 to a technician, and he'll be happy to work for you. Okay, so $400 in if I just convert Singapore dollars, it will be around 20,000 rupees. So a technician, I mean, who doesn't need to be an engineer, he could be just a 12th pass student, standard 12, who has some 6 months or 7 months of training, and then he can work in a fabrication unit. He will be blessed by his analytical mind and his hard work. The person, he or she, would be, I do believe that he will be sufficient to handle machines which are doing these fabrications. So, I mean, that there is an advantage setting up those fabrication things in India. There would be other hurdles, political. I don't know what, I'm not an expert in that field. Yeah, so I guess we need to get some marketing experts from our batchmates, so to answer those questions. But anyways, setting up fabrication and making, starting from silicon wafers, etching, lithography, and implantation, then back-end IC packaging, all those things can be done in India, and it can be done at a lower cost. And everyone understands that worldwide, that if you're setting up in India, you can hire 3 people for the cost of 1 people if they were to set up the same fabrication elsewhere. And the cost reduces. Like if you're hiring a person in USA, you need to pay him $2,000, and for the same $2,000, you can employ 4 people. And just imagine the capability and the amount of work you can put in. And then I would just agree to one more thing. Like I think one of the panelist members mentioned time to market. That's a very, very important thing. I totally agree to that. I mean, time is money, guys, in semiconductor space. I mean, just take an example. I do believe, I think I'm pretty sure that some of you would have used those old Nokia or Samsung phones long back. I was using one Nokia phone, and I remember that I used that phone for like 5 years. And just compare that scenario with now. You buy a smartphone. I mean, I have a smartphone, and how long do you use it? I think the average number will be 1.5 or 2 years. So you use this phone for 2 years, which is much more advanced, but you use it for 2 years and either give it to your father, grandfather, or you just throw it. So okay. So this is one thing. The backdrop is the life cycle of these innovations are very fast. So now, like, you innovate one thing in 6 months or 1 year, and then you can reap the profits for like 5 years. But it's not like that, guys. Now, like, you innovate something, and 1.5 or 2 years from now, that thing is outdated. So you need to innovate again, which means that the overall cycle is shrinking. So as Moore's law is growing upwards, the time to market is shrinking. So you guys need to innovate faster. So you need to innovate it. So whatever things you were doing in like 3 months, you have got to do it in 1 month. And then there has to be a structure or a framework which can manufacture those things pretty fast. So you need very high precision and fast machine. We talk about things like UPH when we, so I work in an industry where we provide these high precision machines which help from the starting from silicon wafer all the way to fabricated ICs to market. We manufacture and make those equipments. And we are talking in numbers, like if my machine is down for 1 hour, the loss is in billions. So just relating back to this thing, like if you're setting up a plant in US compared to if you're setting a plant in India, you can hire 4 people, and the 4 people can at least produce at least 3 times of productivity. So you save 3 times of the time, and you can manufacture 3 times, at least 3 times more number of units per hour compared to if you make them in US. And then even like Asia is a good is one of the biggest consumers. And if you're fabricating in India or in Southeast Asia, then even your distribution, your logistics times reduces, and there are a lot of numerous number of advantages. So yeah, that's what I think. The potential is huge, but one core fact that I would like to focus on that, like for example, I mentioned even in the introduction that it's very easy to find an IT developer in India who is very good in software. He speaks good English and a local language at least. So people are bilingual and they can speak good English. But what I have seen, like what IT industries is in India, like semiconductor process industry is very similar in countries like Taiwan and Philippines. We do not have that knowledge domain as of now. So you need to be a good process engineer who can work in a fabrication unit. So like even it's like you pick 8 out of 10 graduates in Philippines or Taiwan, they will be very good process engineers. We do not have that potential as of now in India. Correct me if I'm wrong, Ravi and Suman. I haven't been to India since, I haven't worked in India, but that's what I know. Like you have very good embedded engineers, you have very good analog engineers, you have very talented mechanical engineers, even electrical engineers. But process industry is again process engineers are not special engineers. They are either mechanical engineers or electrical engineers, but they have had some very channelized courses in their graduate degrees or even masters, which help them to work in semiconductor manufacturing environment. So that is one thing definitely we have to do if we need to dive into this field. I mean, we can't like starting with that, we can't afford to outsource this part to other countries. If you are having a fabrication plant in India, you need to have good process engineers. And even the guys, like I mentioned, a 12th pass guy, you can give them some elementary training to handle those aspects. So that is one area which is shortcoming, which we have to definitely focus on. It cannot be like there is no magic wand for that. You swing it and you have process. So it has to be structured. You have to start grooming engineers from like second year or third year at least. So I believe with those things done and with a pretty average, I won't say average, more than average intellect level, I think there's a lot of opportunity lying ahead of us. And trust me, like I can write in blood and give it to you. Like semiconductor industry is not going to mature in the lifetime of any of us attending this meeting. So 100 years, it was still coming for sure. I mean, you need ICs for everything. Like especially in these pandemic times, there are a lot of bad things, but semiconductor is doing pretty good business in this times, and our shares have grown fourfolds. So I mean, it's a sad thing, but that's the reality. I mean, there are a lot of people using computers and phones and these things. Just take an example over here. I mean, if we were sitting doing the same meeting like 5 years back, there wouldn't have been so many people joining in. So the number of users of these digital devices are increasing. So you need to manufacture fast, and you need to make them faster and cheaper, and with a pretty decent quality. So all these things are on the table, and it's just for us to pick up with some structured training. Yeah, I mean, I hand over to you, Suman, for this round.
Yeah, I think, yeah. So for this, basically, yeah. So I think, Shivam, you pointed out quite correctly about the need for training, basically. So I think in our BTech curriculum, we really don't have a subject, something like an IC fabrication subject as such, to really focus on the fabrication aspect of it. And note that IC fabrication as a subject is not, which is talking just about fabrication. It's talking about designing all kind of complex transistors like that. They are typically heterogeneous. You can go for heterogeneous structures. You can go for the MOSFET transistors. How can you fabricate, and what are the nitty-gritties? So really in our BTech, we don't get that kind of training to pursue further into that field, basically. That is one. Secondly, for your information for everyone, we have Siri Pilani. So Siri Pilani is a VLSI research institute, basically, which has been fabricating But yeah, they have been way behind the market. I mean, I remember when the whole world was working on 14 nanometer, they were still developing 90 nanometer and 45 nanometer chips. But that is understandable because they were trying to actually gain the knowledge over there. I think when I did a project there, it was on heterogeneous structures called LEDs. LEDs are heterogeneous, by the way. So they actually we saw first time 45 nanometer devices present in that Siripilani. So they did everything. So diffusion, they did diffusion, etching, I mean, they made a whole MOS transistor they were able to make. They made LEDs. And for your information, for everyone, there was, I mean, this was the institute which actually developed an indigenous, I would say, LED in India. And then there was a plant set up in Gujarat, which was actually fabricating, manufacturing those LEDs. So there is potential. They are doing research. But the main problem is, as Shubham also said, right? I don't know what the political interest is, because if you look at Taiwan's history as well, Taiwan did a manufacturing industry, but it took a huge debt, a huge loan before going for a manufacturing industry. But it realized that potential, that electronics is going to be the next big thing. You want to automate everything. So if you want to automate everything, electronics will come into there to control. I mean, just think, right? Your cars used to be analog earlier, not analog, mechanical in nature, I would say, completely mechanical. And then later on, now you have a chip sitting there to just control how much of petrol injection has to happen, or the quantity of air that has to go into that so that the combustion is proper. So you need control over there, and then you have a chip sitting there. So it's any field, if you take electronics, or I would say mechatronics, or I would say biomedical instrumentation, all these are actually electronics and instrumentation. Everywhere it is going in. So it's a field which has huge potential. And I think their government realized, our government till now has not realized yet. Maybe that is one thing. And what happens is the curriculum of the industry, of the colleges, right? See, our India has a concept. It's not really a research education. It's more of a vocational education. That's what we basically believe in. We mostly go towards techs. We try to become techs. How much they are going into sciences, basically. So it's a vocational education, and vocational when it is there, right? The whole curriculum depends upon what kind of ecosystem you have in the country. And since you did not have anything on manufacturing, it never came into your course at all. Or it becomes a very small portion, a small fraction, and that's how it has been till now. But yeah, as Ravi was also pointing out, right, that now the government is realizing that. Actually, I remember, I'll detour here. I remember I attended one presentation from ST itself. And I think in the presentation, they told what was the reason why India is not having a manufacturing industry. I remember, I think he told, it was, I think 5 years back, it was maybe a cadence event or a synopsis event. And they told that the total, so to make it, so leave apart the government's will, that is one thing, of course. The second thing, what they found out was that time, those days, I mean, it's still arguable, they found out that the total electronic consumption in India does not meet even a requirement of a production of 1 unit in India. It does not meet that much also. So if you make 1 production unit, you will be investing $5 to $6 billion. And then if you look at our total electronic consumption in those days, it was not matching that. And somehow when they do all this economical fit, they find out that no, we are still not ready for manufacture. In double quotes, leave the Taiwan case, because they realized it long back and they basically went for it. They took a huge debt, and it was a big risk they had taken, but that risk has paid off actually eventually. So yeah, and by the way, a lot of countries have actually failed also. So even I should name that. So there is a European collaboration basically. So today you hear 2 major players. It's mostly either you hear, so Intel has a vertical approach where Intel has its own fabrication, and then you have TSMC, which is basically manufacturing for, I would say, maybe 90% of the OEMs. And then there's a UFC, which is a European Union foundry corporation, basically made by all the European countries. And then there is also a foundry developed by, you must have heard, AMD and IBM. So AMD and IBM actually together, they have global foundries.
Samsung.
But if you look at this, so there is one aspect which is, of course, knowledge, but there is also one more aspect, which is the innovation portion of it. Today, global foundries is actually really sidelined, and it's a super loss. It's going in loss only because the kind of, so what is happening is, as Shubham was also saying, that the cycle has reduced. Earlier in manufacturing industry, you could actually manufacture a particular technology, I would say. So we call it technologies like 45 nanometer, 40 nanometer, 7 nanometer, 5 nanometer. These are all, these require a complete renovation of the entire fabrication unit. So any fabrication unit, when it is created for a certain technology. So the cycle used to be like 4 to 5 years. We used to reap the benefits, but now the market has been so competitive, which is good for us, for designers, but not that good for foundry, that that you only have basically 1 year with you to really deliver as much, 1 or 2 years at max, and then basically you start ramping down and you start adopting the new technology. And then, so that means that first of all, you have to be way flexible in your manufacturing process, that you can actually adapt to the next upcoming technologies. And you also have to basically ensure that you stay relevant, and that relevance comes from innovation. Basically, a lot of research goes into this IC fabrication, because you have to actually scale down. You went from 14 to 7, but you also have to basically improve the performance. You have to give me a better performance per watt from that technology that you are making. So there are, I mean, IBM had something called SOI technology. They had silicon on insulator technology, but then the problem with that technology was, yes, they did thrive a bit, but then as the devices became smaller and smaller, they had super leakage. They were not able to handle the leakage, and then they had to actually eventually sell their server business, not the server, the client business they sold off. And I mean, today it's just running to do more and more research and maybe develop some of the IPs, but it's not really a major manufacturing center. So one aspect has to be there, that if in India we are going for a manufacturing industry, it's not just running the manufacturing hub. We also have to produce an in-house innovation or in-house research, which should be aimed at a particular subject I call IC fabrication. By the way, I did miserably bad because it was too much of chemistry for me when I actually studied that subject. So we basically, there has to be a certain curriculum which has to be aimed towards this particular kind of field. And yeah, maybe in near future, I think there will be some industries. I mean, to tell you, it has been a very, I think India has just kept on delaying this particular field, basically, because I remember there was a joint venture by IBM where they were supposed to set up a manufacturing unit somewhere in Gujarat. And it never flew off, actually. I never heard about anything about that. It came in news and there was like, oh, wow, we'll have a manufacturing unit, and then nothing, actually. It's zero. So we have to basically, I mean, our country has to understand that our education cannot be just vocational. We have to look at vocational and not vocational specific to India. We have to understand that if we want to grow any particular skill in India, we have to do research in that particular area. And we have to basically, we have to be lucrative enough. I mean, one point is there that India is termed as a low-cost geo, as Shubham mentioned. So we are economically, we are viable for all the industries. We are economically viable, but we have to show that we have such kind of subjects and such kind of skill set that we can actually own and deliver, basically. So owning and delivering is where I think the educational institutes have to come up, bring in subjects, bring in electives like IC fabrication in their curriculum, start teaching people on the chemistry, and not just chemistry, I think it's physics, chemistry completely, and mathematics. It's everything, actually. So bring it, groom that knowledge within the students, and then show the world that yes, we have that knowledge where we can actually manufacture. We understand the nuances, the nitty-gritties of manufacturing. So if you open a unit here, first of all, yes, we can run the unit, and Shubham said, right, technicians are there. I mean, everything is automated, but then we also have such homegrown talent which can innovate and deliver even next generation processors or next generation transistors. Like you're going to 7, you're going to 5, then you'll go to 3 nanometer. 3 nanometer, I think, is currently being manufactured. It's being manufactured. I think there's a lot of work going on. And then I think after that, maybe we will saturate Shubham after 3 nanometer. But after 3 nanometer, the focus will go in density. Frankly, I think most of the designs, other than the lesser IPs, are like, they have a 60% density, 70% density. So then people will focus on how to make it more and more dense, how to make it more and more area efficient. So yeah, so that's how the market will be. So I think if manufacturing comes, at least 20 years, definitely it has. and then probably it has to enter into quantum realm. So that will be a different, another set of scale altogether. But there is potential to grow. And of course, pandemic did show that there is a lot of potential. There's a lot of consumption in India. And I think definitely it has crossed that 5 billion barrier, I believe, or maybe we'll be near somewhere, because I think today everyone has phone. Everyone has some of the other OEM typically. So there is a potential, and I think our industry. So I'll give you one more example. It just came to my mind. All these quantum processors, probably you would have heard about quantum processors in the market, right? A quantum processor is not made by a company, I'll tell you. Maybe Google makes it, I'm not sure. So I'm sorry. So it's basically made by a university. At least for Intel quantum processors, they are made by Delft University. In Delft University, there is a whole team of quantum researchers who are sitting there, and Intel has collaborated with them. And then basically they are now making.
Someone, you're muted.
Basically, they have to show that we have enough research in quantum field. I mean, the government has to invest rather than doing all this crappy things. They have to actually invest on education system. First thing, our institutes have to understand that we have to focus on the manufacturing, the physics of the manufacturing. And then basically we have to show them that, yes, we have the talent. You come and develop, and we can actually carry it forward. So that should be the mantra, I believe. I think industry should not decide what kind of education has to be given to the students. It's the universities and the education system that has to decide what kind of industries can come and collaborate. That's the main thing. That would be my takeaway from how basically we can go for self-reliant manufacturing hubs, basically. And I think on the SoC is typically, I think Shubham explained to you, right? The breadboard thing and with resistors, and when you take it at a higher level, it's just it's a processor. A processor is a general purpose thing, basically, which can do multiple tasks. And then you have particular ASICs built around it so that you can actually do a certain kind of specialized task. In terms of SoC design, I feel we are growing. So there's nothing to worry about. I mean, we are growing as a design. India has always been a design country, I believe. We are good in providing services. We are good in designing. There has never been a focus on manufacturing, and now the governments are realizing, but I think it has to come from our education system. Our education system has to inculcate those fields, basically. They have to expose the students, and automatically when the students come with such kind of specializations, automatically the industries will come. I mean, I know some will get opportunities outside, but then they will realize when that there is a pool of students, basically pool of people who can actually work from the country, then of course, India is known as a low-cost geo, so that benefit will be there. Yeah, that's what my take would be. Thanks.
Okay, thank you very much, Ravi, Suman, and Shubham, for letting us know all the things. And I really got too many takeaway points that I have been writing down all those so that I can summarize. So thank you for that. And now let's see into the fourth round of our talk. Like, can we discuss now here what the practical things that we can look into? Like, if we go to the market side, there have been a lot explained by Mr. Suman. And when you are going to the technology side, and I thank Shubham for explaining those things, and manufacturing, Ravi Sharma sir. Thank you for letting us know in the manufacturing field. But when we coming into the practical application, can we just name few products that which are used different technology, and they are using currently an SoC technology, and it will be carried on future, so that someone can be assured that SoC will be there in future, and you can try to pursue them. Open to all the panelists. Thank you.
Today we are surrounded by electronic gadgets. One example is artificial intelligence that is, growing currently worldwide. You use Alexa right in your home. Now you're operating. You have a voice control. With all the gadgets, you are interacting with them. Basically, the interfaces have changed. With the devices. So all these, have become possible because of all these innovations in SoCs and in the semiconductor industry. So, and these things, they will never stop growing. I mean, they will grow many folds. I would say that you are not going to stop using, laptops, tablets, mobile phones, everything. We used to have, watch movies Now, have we ever imagined some 10 years back that we'll watch movies on a mobile phone, on a 6 inches or 7 inches mobile phone or a tablet? Now at least I mean, I'm not talking about the students, but yeah, for entertainment purpose, we now don't use computers or laptops. We use tablets or smartphones. So that's one thing. We are making technological advancement in this thing, and this is never going to stop. So you can say that the industry will definitely grow. Okay, no doubt about it. And as Shubham already said this thing, that this advancement is, I mean, there is no limit to it, basically.
Yeah, it's infinite. Yeah.
Yeah, one example which I would like to mention is it's not a product, but one product is like even your handphone is using a lot of SoCs. They're increasing a lot, especially Apple. So one very relevant example which I would like to mention, and I can't name the companies, but it's kind of like an NDA clause thing. But like companies which I'm working for, there is a huge demand for SoC in the current pandemic times, because like every day you have to do a lot of COVID-19 tests, which is PCR tests and antigen rapid tests. So most of these things are being done. Also, like you collect a sample, and then so these manufacturers of these medical equipments, they also need so they need one important challenge is they need to make those equipments mobile. Like you need to drive them to hospitals or other places to do those kind of tests, and that raises the requirement for your machines have to be portable and consume less battery, and do all the processing in an ambulance kind of thing. So they need a CPU, they need a GPU, they need a lot of memory, all on a small chip. So we have been addressing these kind of requirements coming from medical equipment industry, which is very, very relevant nowadays. So SoCs, a lot of medical equipment manufacturers are integrating SoCs into their systems, and which is also why semiconductor industry is growing in this pandemic times. So that is also one huge market that semiconductor manufacturing and especially SoC is required for. So and I believe sad truth, but health issues will continue to remain for the times to come, and we have to focus some of our efforts into that. And if we can do that by intelligent and compact SoC designs and fabrication and manufacturing, which helps that design, we will be in business and we'll be doing good to humanity as well. So that's one very relevant example which I would like to mention here.
Yeah, I think Shubham might just add to that further. So I think, see, we know, every one of us know that what is the main need or what is the main hunger right now in our society? It is data. Yeah. We need to interpret more and more data. We need data. So analytics basically is now a big field, actually, data analytics. So it's required in each and every field, be it medicines or finding solutions for medicines, be it weather estimation, how you can gauge how the monsoon will be, or be it even smaller. So these are bigger OEMs where you want to see how the Earth's magnetic field is changing. I will tell you, there's an Intel supercomputer sitting in Antarctica. No, sorry, why Antarctica? I said Arctic. Actually, it's in Arctic, which is basically whose whole job is to basically figure out how our Earth's magnetic field is changing. It's trying to compute. It is doing infinite computations. There are big supercomputers sitting there. Then there are a lot of supercomputers which are actually doing weather forecasting. And then there are a lot of one big thing is like we are exploring in space, right? So I think in space, apart there is, I would say, 60% of the automation or 70% of the automation is coming from SoCs, basically 70, or I would say 100% automation is coming from SoCs. So it is basically a growing field. So as we are growing our knowledge, we are in hunger for data. We need infinite computations. So we need SoCs there to be able to compute that. Basically, we don't want to compute that. The SoC should compute and give us the data so that we can infer. So that is one. These are some of the lucrative aspects, or these are some of the fields which I feel will always keep on growing. I mean, there's no limit to it. Because space has no limit, and then the opportunities there has no limit. And then if you go to smaller OEMs, I'll tell you some 2-3 examples. Basically, one example is, I think if I remember the country, it was Kenya. So Intel actually voluntarily went up there and they did a small OEM, which was basically used for soil testing. So it could look at the weather, it could look at the soil, the condition of the soil, and it would tell them what kind of manure or what kind of thing is required basically to grow the crop. So even as OEMs of those nature, basically, so even there you need, there basically they were able to increase the production. I mean, yeah, I saw a big, there was a big mail on that, basically how they were able to grow the production unit. I don't know the numbers, but it did improve over there. The livelihood of people have improved. And even if you look in our country, right? So when you are basically, today a farmer is going and he's talking to different farmer care centers basically, and trying to giving his soil for sampling, and then basically the testing, or that is one way. So even in that way, they're doing communication with the centers where they're doing testing. So we're doing the soil testing and they're getting the report. Even there itself, even in that also, there is an SoC which is doing the whole communication business there. There is an SoC which is helping in soil testing. Maybe it will be purely chemistry, or they could have a device which is actually finding out all the nutrients within the soil and giving them the feedback. So SoC has become now, because SoC means any system, right? It is any system, but which is something which is automated, and it is making our life easier so that we can focus on the critical things rather than trying to do computation. So it is today, it has become an integral part of human basically today in some way or the other. I mean, I don't know, there would be maybe later on, there would be some nuances or some bad effects of it, some ill effects, but today it is a part, and it is basically, it has become an unremovable part of our human ecosystem. So it is, I mean, I think all of us, wherever we see SoC in some form or the other. I mean, other than pure mechanical things, but there is SoC everywhere present, ever present. Yeah.
Thank you very much, Suman. That was a very informative session. And thank you, everyone of the panelists, Ravi Sharma, Shubham Srivastava, and Suman Kumar, for the information that you have gave till now. And the information is very informative, and it is also inspiring for the fellow students, I guess. Now let us move on to the next round, that is the question and answer session. I do got one question from the audience already, and the audience, if you have any questions to ask, please let me know in the question and answer session. I'll be taking on to them to the panelist. As of now, what the main question what we have is like, what are the courses or the road path that we have to go through if you want to pursue SoC? Like we have they are studying, mostly of the students are from electronics and communications, as far as I can see. If you are a undergrad from electronics and communications, further going, what are the courses that we have to opt, or what is the route that we can take so that we can go into the core field and work on this SoC and other relevant topics or technologies? Open to all the panelists.
Well, okay, I'll tell you my path. Then actually, there is a famous saying by E.M. Forster that your path is the right path always. So please, there could be a lot of diversions from that, and I'll tell whatever I know. So basically, microelectronics field starts with, I mean, it starts with devices, solid state devices. So I think that is the base on which you are going to build up your whole career. So you have to take subjects where you deal with semiconductor devices basically, and you can go through semiconductor devices will be your first path. Basically, that will be your entrant, and then basically you can go into then it depends. So you can so first is electronics. Of course, you have to study electronics. You have to study electromagnetism also. Unfortunately, you have to do that because it will be required today. A lot of inductors are coming into the design. So electromagnetism, electronics, so solid state devices should be your subject, and then basically you should go with now you have a basic digital electronics. So you have digital electronics, every one of you. So you have after digital electronics, you can actually fork into multiple paths. So digital electronics, then it depends. So if you want to go into embedded systems, then that's a different field. So by the way, the fundamentals are, sorry, the digital and the analog electronics. So that you will do digital, you will also do analog basics. You will definitely do. I think that's a basic course that you have to finish it off. After that, you have multiple paths. You can either go into embedded systems. You can go into advanced digital circuits and analog circuits. So advanced analog and digital is the portion where you enter into the microprocessor field, and then you have an embedded system field where basically you will go into a lot of microcontroller based system applications. So that is one field that I can think of. So that should be one subject if you wanted to enter into that field. And then I think there are multiple specializations post that in the embedded system. In microprocessor, I can say in the analog and digital circuit domain, I would say, so after you do analog and digital circuits, you actually can go into advanced, as I mentioned, and post advanced, you can actually then there is a IO kind of a field you can do. But those are all specializations which you do as a project. Like they are not part of your curriculum. So you actually end up at advanced analog and advanced digital. And then you basically do it more of something, okay, there are some universities like IITs where you have VLSI broadband communication. So VLSI broadband communication mainly talks about the HSIO field that I work on. And then there are certain courses on PLL. So analog industry is basically broken down into 3 to 4 parts, I would say, or what I know. One is voltage regulators, the low power voltage regulators, where you can do your PhD. And then basically high-speed IO design, which are actually divided into 2 parts, or 2 parts, I would say. One is a broadband architecture and one is a narrowband architecture, where basically something narrowband is more towards RF designs. So you can go into RF domain there. And broadband architecture is most towards the SerDes and DDR that I was talking about. So yeah, so that is one field that I can think of. And then there are PLLs or clocking circuits. So any SoC will not work if it doesn't have a proper clock to really compute. So you need clock. Clock is a very essential part. So then there are PLL designs, basically, whether it's an LCPLL, RCPLL, and all kinds of different oscillators. So all these basically are after you do your advanced, either they are part of your advanced analog design or they come as a specialization that you do post this field. So this is what I can think of. So circuits, solid state circuits, base, and then digital analog circuits you have to study. And after that is where you fork off. Either you're going to digital analog. So you do digital analog as well. That is also basic. And then you fork off into embedded systems or into advanced digital and advanced analog design. So that is the path that I can think of in terms of courses. Yeah, I mean, that's what I remember.
Okay, thank you very much for that, Shubham. And I request Samantha and Ravi Sharma sir if there are any specific fields that you would like to mention, like coming to manufacturing or the technology, any courses or any topics that you should have a like complete grip on.
Yeah, I mean, I would just like to add on. Sorry, Ravi, for jumping ahead of you. Just to some kind of thing like what Suman mentioned. I think we already have the basic foundation. I'm not sure. I haven't gone through the recent curriculum, but the curriculum that we had in our time, analog electronics, it's the core subject. I'll just show you one thing, guys. Like, see, these are my notes from my college 11 years back. So I still have these and I still refer to these. So these are very handy. I still use them. So I just showed you that I still have it. I just took it from the shelf now. So that's the very fundamental course that you have. So don't worry, guys. Like obviously new courses will help you, but I believe you do have like 70 or 80% of the fundamentals needed in your curriculum already. So solid state devices, if you want to go the path which Suman is talking about, analog electronics was one very important subject. I still use it on everyday basis. It's one of the most important, and obviously if you want to fork into the embedded system, you have digital electronics. I don't have that notes, by the way, because I didn't go that way. So yeah, and then apart from that, so that's the basic thing which Suman covered about the design part. Then you obviously like there have to be designers and there have to be makers of those, or execution or making those designs into reality. So for those things, one important thing is you have to you probably need a course on mechatronics. Again, I'll go my way, because you also need to design equipments and machines which can realize those designs. Yeah. So you need to learn those things, fundamental robotics, which is needed, because the IC fabrication and those things are not happening. You might have heard of this thing that's called clean room environment. So clean room is basically machines and which are doing all those process and realizing those designs to give you a final SoC package. So there has to be someone who has to design those machines. So you need to, so few subjects that you need to focus on that is again, fundamental robotics. Control systems is a part of that. Control systems, many people don't like. They feel it's very theoretical, but nowadays you don't need to go into the theory. You just need to focus on the application part. And then apart from that, I have gone through a few courses on platforms like Coursera or other things. And I have seen that even IITs in India have launched some courses which are covering, they are something like also covering like economic aspects of manufacturing, like how much cost you need to pump in, what kind of resources you need to handle. So there have to be designers. If you are aiming for such kind of skills growth in India, then we can't have just designers. You also need to have people who can supervise those processes. So you need to have, there are some growth, like they're not a part of management guys come in and then give some lecture. So there are some courses which are available. They are even available on YouTube for free from professors from IIT. There's a full list of, I just posted a link in the chat box. So there are some courses that you should take, like electronics manufacturing. They also cover the financial aspects of it and the economic aspects with focus in India. So you need to know those skills as well. So I would really encourage all the students to browse through YouTube, and there is a good,
that is
there are abundant number of courses, but somebody has to also focus on the economics of it and how to make those robots or those machines who can realize those designs. So you already have the foundation, so don't worry about that. If somebody is thinking that, okay, I chose ECE, whether I should have chosen EEE or I should have chosen mechanical, don't worry, you made the right choice. ECE, you will have So yeah, and I think the course curriculum is pretty good. It's just that whether you're studying to pass an exam or you're studying how to carry those knowledge throughout your life. So if you have that intent, then the same course textbooks will help you have fundamentals. And then what Ravi mentioned, if you're going for an interview, they won't ask you to design a mixed signal complicated circuit. They will ask you what's a PN junction and how do you make they will ask you questions. So you have to have your fundamentals right, and then those courses which you have now do give you a pretty good foundation.
Thank you very much for that information, Sumant. And over to Ravi Shankar.
Thanks, Tony. I'll just name few subjects. I think Suman and Shivam has already mentioned. Solid state devices, digital electronics, analog, IC technology. Okay, these are the subjects which almost cover all the fundamentals of your, and all these are already a part of your curriculum. So as Shubham already mentioned, 70-80% things are already there in your curriculum. So you don't have to look into other options. First, I would say that make a good command on all these subjects. What all you have in your curriculum already? These 3-4 subjects mainly, which cover almost all the aspects of digital and analog, electronics. And apart from that, after that, you can go for NPTEL lectures you have on YouTube. Okay, that will help you to understand the basics clearly. And if you still have some time left, you need to focus on your final year project mostly. You can take trainings from CDEC. CDEC conducts specialized courses. You can go for CDEC courses also. That will help you in your final year projects also. And you will have a very good opportunity to land a job.
I think focus on your project. That was a good point, Ravi. I think every I don't know how it is in our curriculum now, but I think even in college days also, you should have a project per subject, where basically because that gives you an exposure to what really it is. Otherwise, you can know theoretically, but I'll just give one instance. I'll tell you. So I gave an interview in RRCAT, Raja Ramanna Center of Advanced Technology in Indore, and I did not qualify. And The whole reason why I did not qualify was because they were actually trying to gauge how much I know about the devices in the market. I can tell all theoretical things. I was telling them, okay, this is my noise margin, this is this and that. But then they asked me question, okay, do you know what are the existing things? And my knowledge was just limited to one set of microcontroller, the PIC microcontroller, and then maybe a handful. yeah. So that is where I felt that, oh, so there is a lot of awareness required, and that awareness comes when you do projects on your own, quote, own. And secondly, you basically try to inculcate those devices, generate ideas, and see how you can play with the devices in real world. That will give you a lot of confidence and a lot of learning, basically, in terms of the concepts that you have actually done. In fact, I would say in BITS planning, we used to have one project per subject, and that project used to have 24 marks out of it. So if you are going lower in grades, if you can, and the project actually had a request, it has a requirement that you have to publish it. It has to be publishable. So if you get selected in some conference, you get 24 out of 24. But then if you are not getting selected, then depending on the scope of it, the marks keep on reducing. So something like that should be there. I feel you should be given a competitive environment to actually do such real life projects, such practical projects, and then it should become a part of your curriculum, I would say. Then definitely you are going to learn. I can guarantee that you will definitely learn, and your passion will also grow. Once whatever you think in your mind and it develops, right? Automatically your passion also develops, and you understand what you actually want to do in future. Yeah, use your time wisely, basically.
Okay. Thank you very much for us, Mom. And here, another question that I have received from the audience is like how learning can be fun in this particular area, and theory makes it sometimes a very ineffective. And we can say core has a lot of theory and a lot of parts and so many things to remember. So how can we make it as fun so that we can get interest in this particular area? That's the question from one of the audience.
Earn some IC, guys, you'll get interested.
Yeah.
we did a lot.
Yeah.
Sorry, HOD ma'am doesn't know that we burned a lot of IC in the lab. So
yeah, I think do more practicals. Yeah,
that's just a fun for it. But like, for example, like you do a lot of your subjects studying, you will study OPAM someday. I'm pretty sure if you go up to the lab, you'll have those 742 or 743 ICs. Try to
forgot what this is.
Yeah, it's a differential amplifier. Try to find some, burn few of them. I believe we still have the budget to afford those things because they're pretty cheap. So plug them into breadboard, have fun with the oscilloscope. See, guys, I mean, definitely that's where we triggered. I mean, as Suman also mentioned, your path is the right path, but that's what I remember doing. Like that got me in, that got me interested into the field. And that interest is still growing. So I burned a lot of ICs. Even the study microprocessor 8085, please do go out and enjoy those practical sessions that are conducted. Maybe not very frequently, but play around in the lab, guys. Spend some more time. I mean, definitely if you see those analog ICs burning out, or you'll have the curiosity to know why it burnt out and what you need to do differently next time on the breadboard to connect it properly. And so you get a half-wave rectified sine wave or things like that. So if you see those things like half-wave rectified, maybe these are just bounces, but if you go and study that chapter on half-wave full-wave rectification, and you see those things on the oscilloscope, 99 in 100 people will get interested by that. And that will be enough to get you going for the next 20 hours for the theory sessions.
Okay, thank you for that, Suman. And the next question that is from the same audience hosts is like how much knowledge of coding is required for an EC engineer, and what are the coding languages that you would recommend if they would like to get into the core and SoC?
So one thing, I mean, there are multiple options available. I mean, one is Tickle, another one is Perl, Python. These mostly these three languages, you need to have a command. And one thing that industry is going through a lot of automation because one thing we want to save time basically. So for that, we need automation, and automation is possible with the help of all these, coding languages. So I would suggest go for Python, Tcl, Perl, anything out of these.
I'll just add one more, Ravi, to it. Ravi, okay. By the way, I work in pure analog, so I hardly do any coding. But as Ravi mentioned, right, they help us in scripting though. Like there is a humongous amount of data which we want to process. So, but I think you should have a very good command over Verilog. Why? Because today the world is trying to model. So today when we do design, right, at least in Intel, we do have behavioral models of each and every design. So if you have a very good command over, I mean, that has now become an additional skill set. So what happens is in your design cycle. So by the way, in Intel, Shubham, I mean, in Intel, the design cycle is pretty long and maybe we are not that efficient. So it is, yeah, I mean, I would tell you for your information that I spend almost 3 years with one design. And as I told you, right, it's a full custom design that you have to tape in and then you have to silicon test and silicon prove it. And you won't believe that the testing happens for 1 year before it enters the market, by the way.
I know
2 years designing and then
Intel is my customer, so I know the
story. Yeah.
So it took almost 8 quarters to do a chip in Intel.
I don't know. Somehow I think maybe we are very inefficient, maybe, but it takes that much time. I don't know. Somehow not able to. Yeah, I mean, we tried. I mean, we did just for your students and all. I'll say we did a 2x speed up in the whole existing DDR. We did it in 7 months, but that we could do for a test chip. Okay. Once we went to a product, it has taken us 1.5 years to make the design for a product. So it's basically the amount of variation that you have in the real world is so high that it takes that much time. So, okay, but back to the topic. On the Verilog front, what I'm saying is today, a lot of companies, even with likes of Apple and Intel, I know, maybe Qualcomm as well, maybe. So they are actually focusing on behavioral model of your systems. They want to get a behavior model. They want to simulate and see whether your system is working fine or not, basically, whether the digital encapsulation that they have around their IP is fit enough to do any kind of processing based on the analog data that you have got. So that is one more field where you can actually grow yourself and you will get a very good opportunity as well. I mean, be it any SoC, be it any IP subsystem, it requires an RTL ecosystem around it. And then the path to go there is Verilog. So be very good in Verilog, be very good in digital electronics, be able to convert those, make synthesizable models of those digital electronic concepts that you have studied about metaflops and synchronizers and everything. And then basically you are good to go actually. So Verilog is something that I feel is equally important basically in terms of a coding skill set. Yeah.
Okay, thank you for that. When we are speaking about this integrating, knowing the behavioral aspects and all, stimulating, can we know what is the role of VLSI in the stimulating aspect and the behavioral, not might be the completely into behavioral aspect, but in stimulation of the embedded system, can we know what is the role of VLSI? If we pursue into the VLSI aspect, can we still land into the core field and can we deal as much as we are dealing and like practically doing it without burning all those, I guess?
No, by the way, for your information, embedded systems is VLSI. So it is everything is basically inside VLSI. So VLSI is everything here. So maybe Shubham, you can answer this question. I don't have much information on the embedded system part of it, basically.
I mean, yeah, I mean, there are lots of simulations that you can do for your, not sure, like, I'm not fully aware of the simulation for the, maybe Ravi could chime in here.
Okay, Ravi, yeah, one second. I have one idea. Yeah,
FPGA and all.
Yeah.
Okay, I have one example. I'll tell you. For example, a CTLE is an equalizer, basically. What is CTLE? So how it is used, I'll tell you. The equalizer is something, so when you have a channel has a low pass filter characteristic. So when you send the data, it will attenuate in different frequencies in a different way. And what you do is you try to create an anti-channel, which is a asymmetric, it's called a symmetric receiver. So you try to create an anti-channel transfer function. So when you create an anti-channel transfer function, it's basically a kind of a high pass filter because you want to replace a low pass filter. So you have a low pass filter data. I hope low pass filter is known to you guys. And I'm sorry for those jargons. So you because I don't know how to go below that. So you have a high pass filter. So you try to now this high pass filter design, right? For example, if you really want to make, so there are multiple ways to make it. One is, of course, you can go into MOS transistors and try to. So this high pass filter design is actually a spec. The spec can be easily modeled in a behavioral model. And by modeling this this equivalent of this circuit CTLE as a behavioral model, you can plug it into your system and see whether this kind of spec is working or not for a given kind of a system that I have. When I'm sending the bits, am I getting the right bits or not? So this is one example where nowadays the whole SERD is an infra, which is basically a transmitter, a channel, a receiver, and in receiver there are different types, and then a clock data recovery system. The whole system is actually, it is being replaced by a BMod first to come up with the golden specs. And then there are other things. There's also MATLAB. You can even model that in MATLAB. So they're coming up with this behavioral model, which is pure Verilog, by the way. And then basically they are actually now, so they define the specs based on that. And once you define the spec, then you say, okay, so if I'm going to do a transistor design, this is what I'm going to meet. So they are trying to make even behavioral models, or the coding part of it, right? The Verilog codes, they're trying to make it more and more elaborate to mimic the system behavior, basically. So they can even get even more. Like, I know I need a high pass filter, but I need a resolution of the high pass filter. So if I need a resolution, can I model a behavioral model where I can define what is the resolution of that high pass filter and then basically put it in the system and see which resolution works best? So there's no limit to what can be modeled. But I'm saying industry is going towards this way, because what happens is in a design cycle of 3 years, in the first 2-3 months itself, you'll know, okay, what kind of model I'm going to build for the next 2 years and come up with it. So that is one field where I can actually see how behavioral model usage is growing a lot. At least I see that a lot in my team as well, where every designer is supposed to make a quite accurate model. And then basically with that accurate model, we run it in system and look at, okay, how my system is training, how is my system performing and all. And we try to ensure that our design is trying to meet that theoretical model, basically. That's one example of how the behavioral model is used in a system design. Yeah.
By the way, some of the simulation tools which I am using for discrete components is like someone mentioned MATLAB. MATLAB has very nice toolboxes. One is SimScape. So SimScape lets you do some basic electrical analysis as well. And then back in college days, I was using this tool called Multisim from NI.
Okay.
To buy some. So I was able to do some basic, circuit analysis with that, which you build those kind of circuits in your lab in your undergrad. So that's, and those are poor man's tools. I guess Suman and Ravi are using more sophisticated tools.
No, I use Simulink mostly. I am a Simulink user because I'm comfortable with that. MATLAB Simulink, I'm a comfortable user with that.
And SimScape toolbox in MATLAB will be, for beginning stage, I think that will be enough to get you going.
Yeah.
Okay.
Yeah.
Thank you. Over to Ravi Sharma, sir.
Yeah, one thing I would like to add here. So, when you design a chip or when you, go through the process, you get the code first. There is a team which, based on the specs, design the code, again, in which VHDL or Verilog. So during that whole process, till the tape out process, there is a team, we call it DV, design verification, that specifically works on this thing only. They just simulate all that code, and different environmental conditions. They try to find the functional bugs also, whether the design is going to work or not, right? And they use MATLAB, Simulink, and everything. They do coding in C and C++ also. And they basically simulate all these things to see whether our design is going to work or not. Over the time, they found, I can say that they found a lot of bugs in the design. We fixed them. It's an ongoing process during the whole cycle, 8 or 9 month cycle. It's an ongoing process. They get the code corrected. We get the updated code. The team again work on the same things. They do simulate those codes as well, and they unless and until we are sure that the design verification team says that okay, we are good to go now. There is no bugs we can find in the design. We have simulated every aspect of it, and we are good to go. Then only we can go into a full final cycle. So it's pretty important, basically.
Yeah. I think for MGR, I think they should include a subject like something like a mixed signal validation kind of a subject or verification subject should be there, which is today missing in all the, even I think even it's not there in IITs as well. So the universities should take such a subject. Basically it talks about all kinds of stuck at faults that can happen in the system, and how you can actually, that's a whole stream, how you can debug those kind of issues, basically whether you go for scan chain there to debug those stuck at issues, or if there is a manufacturing defect. So it's a whole topic that actually, it's a whole field which is basically people learn in the industry, but I think that should go in the universities. And again, that will be lucrative for the companies when you have an additional knowledge of that. And that is a separate field. I mean, it is all VLSI, by the way, everything is VLSI, but it is another niche skill set that you can gain, and you can directly get a job as an MSV validator. Basically, it's a straight away job. You don't need to go as a separate path and then take a branch off. So that is something that should be there. Yeah.
Cool. It was very good information. And the next question that we have from the audience is like, what are the courses that you have to take on to meet the current company needs, like the industry demands? What are the courses we have to keep focusing on? And are there any particular internships or the companies that we would like to get into internships, so that might be helpful in our placements or like job validation or something? Or to all the panelists.
So on the internship part, I mean, it's a different thing. You know, you may get a chance for an internship, you may not get a chance. I would say in final year, if you don't get a chance, just go for some courses like I mentioned. CDEC conduct some courses. Okay, and there are other institutes as well which conduct some 6 months or 9 months courses. Go for those courses if you don't get a chance in internship. And it's not that if you haven't got a chance for an internship, you will not get a job. Okay, so first focus on
the
all
courses that we have to mainly focus on, like in courses.
For BTech grads, there are courses VLSI design, and they cover all the aspects of it. Digital analog part. There you need to decide what you want to learn, or based on your interest, whether you are more into digital part or analog part. That's where you need to decide. But I would say that cover basics of all the things. Okay. Focus on your specialization where you are doing your project. That's the main part.
Thank you very much for that, Mrs. Ravi Sharma. And the question, we have two more questions left. And one of the questions is like, is there a technology like Li-Fi? We can hear a technology called Li-Fi. Is it associated with SoC, or are there any opportunities and research that's going in that Li-Fi technology? That's one of the questions from one of the attendees. I am not very well aware of this.
I am not aware of Li-Fi, so maybe Ravi and Shubham.
Not aware of it.
We heard that it was theoretically approved, but practically it was not that technology. It is generally accumulating the energy source from the living things and transferring it to the photons or something like that. We heard somewhere in my second or third year, but not aware of those. And the one who asked it, we'll get back to you on that if possible. I have noted your name. Thank you for that.
I mean, it should be in the the term should be there, but it hasn't been somewhere to the industry level or realization as yet. Would be good.
Not that.
Maybe it's a research topic. I think research is going on in the initial.
And I believe it hasn't gone to lab level yet.
Okay, thanks for that. And the next question here we have is, what will I think it is specifically for Suman Kumar Panda sir. And the question is like, what's the situation like for preparing GATE and post-GATE? And the another question is for all the three panelists is like, what are the master opportunities for going to masters, opportunities, and the marketing technology, etc.?
I think I'll confine my answer to India actually. So, and Shubham can talk about the universities outside.
What is the situations like in GATE preparation?
On the GATE preparation, I think guys, just start preparing as soon as possible. I would say from third year itself. Yeah, maybe. So if I remember, I started from third year.
Yeah, we started
third year, second semester. Third year, second semester, first semester. I don't remember that, but I started preparing. So it was even before I got the job actually. But I started it early, and it was good actually. I mean, yeah. So we used to I used to study. Okay, we used to do classes till Friday, and then I think Saturday and Sunday I used to go to, if I remember, T Nagar. There used to be a Vani coaching institute where I used to prepare for Vani classes where we used to prepare. Yeah. And and that's what. So yeah, it was a additional effort that you have to put. So that is in terms of GATE. I mean, you have to build your concepts and then go through GATE papers and solve that. That's the only thing that you can do. What else? So yeah, that's from GATE perspective. And what was the other question? I can't hear actually.
Pavani, you're muted.
Yeah, thank you for reminding me. Actually, I think the question is like, what are the options for masters and courses you have? I think the question they would like to ask is like, if you are preparing for masters, what are the things you have to consider and the technologies or courses that you have to look into?
No, I think first of all, you're preparing for GATE, I believe. I think in India, if you want to go into a premier institute, GATE should be your thing. And as Ravi, Shubham, everyone has iterated and every one of us is iterating. And we have realized that just get your fundamentals correct. And our Indian style of education is not really, it is not really, the exams specifically are not, so fundamentals will help. They are basically looking at your skill. Sorry, so I was just trying to think of what I can say. The Indian education system basically sees how easily you can solve problems in a given time, how fast you can solve problems, right? So you have to be skilled here. So if your fundamentals are correct, you will be able to understand the problem, but then you have to practice a lot to be able to solve it. Because, in nowadays, I think we were like 1 lakh people attempted for EC, but now I don't know what is that number. It would be exponential, some order. I don't know what it would be. So many people, and the ranks will slip. Even if you have one answer incorrect, your rank will go down so much actually. Like, I don't know, like you can be in an in and out phase. So get that skill by solving papers for GATE. That should be your first thing to get into a premier institute. Yeah, Shubham, you are saying something?
Yeah, I think the other question was like PSUs and also I believe GATE score will help you with those PSUs also. Like if you have like, I don't know if you have like.
Now everything is GATE, I think, Shubham. Yes. All the PSUs also take from GATE. There is no separate exam.
They're taking from GATE. Even I had some interview calls from PSUs. I didn't get through, but talking about master's program, GATE is, I think, the one thing that you need. If you're talking about universities outside India, then universities in Asia specifically, they do consider GATE score. That's how I came in here.
Yeah.
So on top of GATE score, like if you come to two universities in Singapore, so they are ranked like 11 and 12 in the world, NTU and NUS here. So they do consider GATE score. I didn't have a very good score, but a pretty decent GATE score. And on top of that, you will need to write 2 of the English examination, either of them, either TOEFL or IELTS. So you need to have a pretty, not very high, just a decent score. And I guess since the medium of communication in engineering is mostly English, so you guys will sail through that. So that's the story for if you want to go for universities for master's program in Asia. Singapore does a GATE score. So this.
How about GRE, Shubham? Can you put some light on GRE?
That. So universities in Singapore and in Asia. Even in Philippines and Thailand, they do consider GATE score as well as GRE score. So if you're preparing for GATE and you're aiming for universities in Asia, you do not need to write GRE. But if you're aiming for universities in US, Germany and all, they do not consider GATE score, so you need to write GRE. So for GRE, so for that, you don't need to write GATE. So, but I guess the common cycle, the common thing is that even we went through the same thing, that we are not very sure whether we will pursue a higher degree in India or abroad. So you finally end up writing GATE anyways.
Yeah, that's true.
So you have to write GATE, and then depending upon whether you want to travel to Western side, then you need to write GRE. And I didn't prepare for GRE, so but probably like you need to put about at least 6-7 months of effort for GRE. I guess some of our fellow students, they did appear for GRE.
Yeah.
So Yeah, but if you're aiming for India and universities in Asia, then gate score will get you through. And then on top of that, you will have to write either TOEFL or IELTS. If you're writing IELTS, then do make sure that because of the pandemic, you need to book your IELTS date in advance. So like if you think your gate score will be available sometime in July some year, then you should write your IELTS exam sometime not later than April.
Okay.
Or May.
And how many years it is valid? One score, Shubham?
IELTS score is valid for 2 years.
2 years. Okay.
IELTS is also 2 years.
Yeah. So gate score, I'm not sure, is also valid for 2 years. Back in our times, it was 1 year. So they kept flipping 2 years, 1 year, 2 years, 1 year, and we were the unlucky ones when it was just 1 year.
No, but does the rank stay the same, Shubham? I mean, does it, by the way, guys, the rank stays the same? For example, you got in first year, you have a 19.6 percentile or whatever rank you have, then it will stay the same for the second year, or it will change based on the...
Well, I'm not sure of that because I didn't go through that, that yet.
No, I'm just curious.
We all capitalize on our rank in the first year, but I believe your marks will stay the same, and in case the metrics will change, they will just recalibrate your marks based on that, and then that's what I believe. That would be the most intuitive thing to do, I believe. But again, if you're writing IELTS, you need to put in like 1 month of effort. Just try to read. The Hindu is quite popular over there. Read the Hindu; it will help you through to get a bump in your score. But do write IELTS or TOEFL like 2 months before you are getting your GATE exam results.
Okay. Hey, Ravi, can you just tell about the institutes that they should target? Do you have some information that
no,
they should target?
You have to give GATE, right? Anyways, if you are targeting for bigger institutes, you have to give GATE exam.
How about the triple ITs? The triple IT Hyderabad and
they are in GATE. They are
in GATE. Okay. Yeah, I think GATE.
Okay. And remember, you have to fill their application form before GATE application form. They give
one thing.
very early. Yeah.
CDAC also conduct the MTech now. Specialized courses, and I think they have a separate exam.
Okay.
Yeah,
I know that. Yeah.
Yes.
Yeah, thank you for that enormous information for all the panelists. And the last question we have for the session here today is, for job in SAT field, what is the best way? Which skills are required? Like SAT. Someone.
SAT, is it that MBA one, or are you talking about? No, SAT is what?
I'm sorry, the name is anonymous attendee, so I might not know. If guys are listening to this question, you can just type it your question again, whether it is what do you mean by when you mention SAT?
I think it's some exam for universities in USA.
For a job in SAT. Okay, I got one more question. Let me quickly check it. It is SAT, STA.
Oh, static type.
STA. Okay.
My mistake, pardon.
STA is one of the domain. When you land a job, it comes after that only. So you can have basics of STA. When you are pursuing your post graduation, specialization in maybe microelectronics or VLSI technology. I mean, different university or colleges have different names for the same thing. Some call it VLSI technology, MTech or ME, and some call it microelectronics, IC technology. So this is one of the domain where you can, specialize, or you can enhance your skills, and maybe once you land a job, you can choose that profile. So that's what you do there in this profile is you do the timing analysis of the chip. Okay, at the IP level,
be good in digital, I think.
Yeah,
be good.
Yeah.
Be very good.
That's the digital part. Yeah. So that's my profile basically. So I've been working for past 9 years on the same thing.
So
and I think you work at an SC level, right?
And what is the best way, and what are the skills that are required to land into a STA job?
So I would not say STA job because once you say that you are looking for a job in STA profile, that's for the experienced people in the industry, those who already have an exposure of the industry. For fresher, I mean, because we are talking in that context only, right? So you don't decide before that, at this point when you are a fresher. You first have to land a job, and cover all your basics of digital and analog electronics. You don't have to worry about digital verification or static timing analysis or VHDL coding. I mean, you must be having some basic idea about it. VHDL is part, Verilog or VHDL is part of your curriculum. Digital electronics is one thing. Yeah, you can say that closely. If you want to work in STA side, you need to have more focus on digital electronics part. That's one thing.
Yeah, I think I'll just add one more thing, Ravi.
Yeah.
I think, Ravi, there are certain, so at least in BITS planning, there was a course called EDA tools. So EDA tools actually did expose you to clock tree mesh, basically. So because we're talking about STA, so it did expose you to clock tree mesh, and
they more work towards the verification side, basically. They more work towards the verification side. Yeah.
Okay. Yeah, but that is a good thing that you can take as an elective. It will also give you some knowledge on,
right?
Yeah, maybe STA, I don't know, maybe. Yeah. Okay.
Okay, thank you for the very informative Q&A session. As of now, with that, we has no more questions left in our question and A section. Glad to know that. And if you still have any questions, attendees, you can always reach out to the event organizer, I guess, or someone who organized this event, so that we can come back with answers if possible. And now with that, we'll come to the end of this event and the summary of the event. So is there anything else that anyone would like to point out or anyone would like to discuss? I'll give you a minute. Please come up and please let us know what is anything else that we would like to know. And if not, let's move on to the summary.
Shall I go with the question?
Yes, ma'am, please.
Yes, as Shubham was talking about this economic aspects, I just wanted to know what is the impact in the semiconductor market. Okay, due to this COVID-induced lockdown, there may be a restricted imports for semiconductors or microprocessors as well. So what was the impact in the semiconductor market?
Okay, yeah. So maybe I'll take up that thing. So, I mean, we did have some hiccups with the supply chain initially, because, the hiccups were basically not because of shortage of material. The hiccups were just because those were turbulent times, and many of their logistics staffs, because they need to work in person. And so a lot of people were getting infected, and so the human resource factor was dipping down. So if a logistics company had 10 staff, they just had 2 staff on the floor to work with. So there were some hiccups, but it was not because of shortage of material. So it was, and eventually I think back last year, sometime in October, September, the second last quarter of the year, that's where we had some hiccups. Things look stabilizing now, so we are not having any issues like we call it lead time. Like when you order raw materials, it will have a lead time of 4 weeks or 8 weeks. So those lead time grew by about 25%. So something which was coming at 8 weeks was coming at 10 weeks, getting delayed at some places because of lockdowns and things like that. But eventually it is easing out, because people have learned to live with that. And again, thing is that people have hurriedly started automating most of the things, like scanning and those things. So we are not specifically in Singapore, we are not running anything on shortage of material. But it's the whole industry knows that there might be some delays here and there. So some of the things we import from Japan, it comes via Hong Kong, and Hong Kong was going through another political issues. So things were getting delayed over there. But people have started to come out with ways to live with those things, especially the logistic companies. So it looks like, again, getting back to track. I mean, if any things like that, it will be, I believe, not very long-term impact on the import of those things.
Thank you very much.
Yeah. So I didn't really face a lot of significant blockages because of that. But anyways, one good aspect of this thing is what we call in our industry if you're getting some delays, like what Suman mentioned, the life cycle of some innovation was 7 months. But if you're innovating something and then you're expecting for some hardware to arrive after 7 months so that you can actually realize your design, and if you're getting a 2 weeks delay, trust me, it's a blessing in disguise. You always are 1 day short of your project, no matter how much. So those lead times actually helped us to improve upon our design and do the same thing in a better way. So
Yeah, that's true.
I was sometimes like very happy. Okay, I'm ordering a motor to work on a robotic end effector. I need to write the control systems algorithm, the motion control. I'm pretty much sure. Okay, fine, it's done. The motor is arriving tomorrow. I'll test it. But okay, I get to know, oh, fine, it's delayed by a week. Okay, I'm very happy. Okay, I can again improve my design. So that comes after a week. So take it as an opportunity. If things are getting delayed, you can use that for good development work. That's what we when
but Shubham, it's a loss. It's a big loss for corporates, basically.
It's a loss for corporate, but I'm a bit selfish on that. So, but it gives you because we also say that once you're going through a recession, or there are some delays in the things, it's a very good time to get back to the drawing board and innovate more thoroughly. So there are some good aspects about that. Obviously, time is money.
Be positive and take positive.
Because I thought like this impact should be an initiative for a self-reliant SoC design. That is why I raised this question actually. Thank you very much.
But I think I don't think so. It is a. By the way, I mean, I'm just saying it's not really a factor for self-reliant SoC. I mean,
not exactly, but
yeah. I mean, self-reliant SoC is a different thing from our country and our government and our people's perspective. I mean, these factors will happen, and there'll be other factors that will come which will slow down the whole process. But I think they are. Yeah, because today, ma'am, what I wanted to say is the whole world, every product is a macroeconomy in the sense everything is related. You get something from US, you can do something in Japan, you are doing something maybe from India, you're doing from some other country, and then you get. It's the whole logistics which is basically delaying this in a way, basically. It's not really that. So I'll tell you from Intel, right? Even though Intel was, my timelines did not change. We delivered on time, basically. There was no impact at all. We just did our design and we just delivered. But the thing is, for example, a product has to go somewhere for testing. Like, for example, in Intel Arizona, there is a factory where you manufacture the product, but then it has to go to Penang for testing for a particular kind of a feature. So those things were where the things were getting delayed, basically. The logistic part was actually impacting.
Yeah, and like even from the manpower, like you have to send some engineers to Arizona and then you have to fly to Penang. There are a lot of restrictions from US to Malaysia. So things were getting delayed there. Like employees who fly from Arizona to Malaysia, they have to be quarantined for 14 days.
Exactly. So those are the
logistics. Also into the same thing. I had to fly, but like even when I'm working in the lab, I have employed some very crude techniques. Like I have cameras near my machine, so I can work remotely more equally efficiently. Obviously, sometimes you need to go to the lab and get your hands to it, but it's not a showstopper for now. I mean, you could. I mean, we tend to come up with some out of the box ideas, especially in our country. So
yes.
So we come up and even with pandemic situation, we are trying to grow to learn and to work remotely more efficiently.
I think Shubham, just I would say India is a very good low-cost geo for any field. So remember the term low cost. So if we can harness the skill set within our country to be able to handle those, and we always have a low cost tag to us, definitely companies will come and basically develop their sectors here. So I think
totally agree with that. So even my company is exploring that idea. We are very soon opening an R&D center in India. The motive behind what our CEO said is because you can hire an embedded systems engineer for 1/3 the cost. And
it's all about money. It's all about money.
It's all about money, yeah.
Yeah, it is.
Yeah, it's really
all about money, but also quality. You get good quality engineers, equally good quality engineers in India. Then you get and for I mean, it's a very simple math. You go to buy anything at grocery store, you'll buy, if you're getting the same thing at cheapest anywhere, you'll buy the cheapest one. So it's the same thing. It's very natural to go for that.
Yeah, that's true.
Hey, that was, yeah, that. Thank you for that information. It really gave another perspective of doing everything at an industry level. So, okay, there are many factors that were included, and if one gets profit and other gets luck, everything should be balanced to sustain in the industry with this kind of competition and this 4G and soon to be completely 5G world. Okay, let's come to the wrap-up session of our very wonderful event. If you ask me, it went quite well than I expected. So to summarize what we have learned, I got so many notes, but I'll just wrap it up in 2 points. That what I learned is like SoC, which is a system on chip, has at the current time, it has a lot of scope, and future there will be much more scope based on the current conditions, and there is much more time it can prevail in the industry, which includes a lot of other aspects which we have to focus on. So one, if we sustain what all the paths, what are the difficulties that you come across in the code field, and concentrate and deep dive in the basic knowledge what you are understanding in a undergrad, and make sure you select the proper path in your masters or and straight away to the job. If you have the skill set, and if you continue pursuing our practical ways, then theorized and conceptualizing everything and putting it into practicality and focusing on the product. And like what they have said, abundant opportunities can be made, and everything, it can not only include and improve our personal information and everything else, it can be also be improved in the national wise economy and the status. So the universities also have to indulge in more practical ways to get into the core subjects, even though if the students might burn some few processors and transistors and resistors, that's okay. They, if possible, they can still try to incorporate more practical sessions which might trigger interest in the students, and which might lead more and more people to come into the core field. And they are India also to try to invest more in R&D. If that is the case, we want to more manufacturing sectors or the areas, they have to be more into in the R&D sector too. That was the takeaway, and thank you for answering much more other of the topic questions that were also being questioned. So sorry for me. And the conclusion to all is from the bottom of my head, I thank each and everyone who is present here, the panelists, especially for taking out your time from hectic schedule, and there might be a time difference for you also. Some of you are not might not be here working here, so they have time differences and time lapse. Thank you very much for taking out your time, and I extend my heartful gratitude to all the organizers, attendees who made this event very successful and organized it very well. I thank you very much for panelists taking out your time. And I wish you a very great success for everyone present here and who are all watching it somewhere. Thank you.
Hey, thank you.
Yeah.
Thank you.
Thank you, Pawani. Thank you, Pawani. Thanks a lot.
Thank you very much. And with us, we conclude this event to come and successful end. Thank you.
Thank you. Bye.
Ma'am. Ma'am.
Yes, sir. Yes, sir.
Madam, vote of thanks to
Yes, sir. We can go with.
Okay. Yeah. Good afternoon to everybody present here. Okay, I'm FAT. Nothing.
Lakshmi, sir, your voice is breaking.
Hey, Shubham, but 5G cannot solve this issue. I'll have to put so many towers in the vicinity.
Am I audible now? Am I audible?
Yes.
Yes.
Yeah. So,
Thank you for all for being here, and sorry to interrupt. I do have my office that I have to join in next 10 minutes. So, but as of now, I'm leaving. Sorry for the abrupt leave. Thank you, everyone. Bye.
Thank you, Pavani.
Pavani, just a moment. We'll take a screenshot. Then I'll render the vote of thanks.
Sure, sir.
Rahul, are you there? Rahul? Yeah, you just take the screenshot. I'll come in video just a moment. Have you taken? Rahul, you have taken the screenshot?
Anyone with a laptop can take a screenshot in a window view. Yes, anyone can take it.
Okay, I have taken.
Yeah, okay. Shubham, you send me. Okay.
Yeah, sure.
Thank you.
Right.
Thank you, everyone. Have a good day.
Thank you. Thank you, Pavani, for being the moderator. Thank you.
Leaving in between. Thank you.
Okay. It gives me immense pleasure to thank all those who are behind the successful completion of this 16th day of this alumni conclave, right, which is being conducted by our department. So first of all, I would like to express my sincere thanks to the panel members, Mr. Shubham Srivastav, Suman Kumar Panda, both from the 2009 passed out batch, and Mr. Ravi Sharma from 2010 batch. So despite their busy schedules and previous engagements, they have agreed to come on the board, and they discussed about the intricacies of SoC design. On behalf of our department, we once again thank you all, and I must thank our management and the executives, and particularly the MA Association, for standing behind us in each and every endeavor that we do for alumni students. We also like to express our sincere thanks to Dr. Geeta Lakshmi Ma'am, Vice Chancellor, Dr. Silraj Sir, Additional Registrar, and our HOD, Mrs. Jayalakshmi Ma'am, then Deputy Dean, Mrs. Kriba Devi Ma'am, of course, the Dean Ramesh Sir, who, although not present today, was behind this conduction of the entire alumni conclave. So it started off with nothing actually. I used to call each and every person in India as well as in abroad, people who are there. So it has been really a big experience for me, and I'm happy that when I used to talk to a lot of people, I have come to understand that a lot of our students are working in different parts of the world, occupying top positions in reputed companies across the globe. So it's very heartening for me as a teacher, right, that my students are reaching higher positions. So once again, I thank you one and all for being a member of this alumni conclave event, and I hope that the key takeaways of this event will be how to develop an SoC design with low cost that are quite available in India. So you know pretty well that some 50 years back, people were flocking to abroad. for lucrative positions, top careers. Now the foreign companies are setting facilities in India. That shows the real human potential of our fellow Indians who make this happen. So, as a mark of respect, Indian professionals. So we thank you, the panel members who have made this happen, and I hope that this event will be a grand success. I think it has become a grand success, and this success actually comes from your participation in this event. Thank you, one and all.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, Ravi, Shubham, and Suman. Thanks a lot.
Thank you, sir. No worries. We'll be
Pleasure, sir.
glad to be part of this conclave.
Yeah. Yeah, we can guide a bit, I guess. Yeah.
Thanks. Thanks, Suman. Thanks,
Okay,
Shubham.
I'll sign off then. Thank you. Bye.
Thank you.
It's
Bye.
great that you have been. Ma'am, shall we wind up, ma'am?
Yes, sir. Yes, sir.
Thank you.
Thank you all.
Thank you, ma'am.
So we'll have some other sessions for faculty development as well as student development programs, if at all there is anything out of it, right? Suman, Sumam, and Ravi. Okay.
Okay, sir.
Prasanna, the recording stop பண்ணிக்கலாம் சார்.